Alright everyone, welcome back to part 2 of what was supposed to be one large stream, but ended up being cut in half. It's neither here nor there. Let's get rid of that. So, we basically finished with the first pass of the texturing of this guy. Now, I kind of thought about making perhaps a few small changes to this, because this thing is a little wonky looking. So we're gonna see if we can actually make those changes without the textures sort of breaking, and see if we need to rebake. So this particular corner is the sort of the biggest sort of nasty thing here. I feel that looks kind of okay. We can see that the edge highlight which we have here going here is actually like just disappearing because it loses the whole sort of the whole corner there in the UV space, right? So it looks like that. And then if we drag it here, it will move here in this as well. Oh, actually, it's because we have that option on, right? If we do that, now, oh, it still does it. Okay. Well, doesn't really matter. We can probably go in here. Come on. Let's see. There we go. And just move it back like so. And that should work kind of okay. You can see it in the actual editor. We have a pretty sort of hard edge here all of a sudden, which like I felt didn't really look very good. Also, the SSAO is kind of adding a little bit of, you know, too much AO here in this crevice. So with this, I think it should look vastly better. But now, of course, we have this thing where there's still like a little bit of a pit here in this side of the whole, well, side of the cliff. So let's maybe add this extra edge here to make it a little nicer. And we're just gonna export over the old one. And yeah, maybe that looks a little nicer. It's worth keeping in mind that we shouldn't really actually see that side of the cliff as the player, like, ever. So it should be fine. Hello Mint, welcome back. For some more game dev. Let's make sure I have my mic set up here in such a way that I don't accidentally hit it, but I also can be heard. Let me know if the audio levels are somewhat decent. So I mentioned here before the break that we might want to actually paint a little bit of this yellow stuff on top of this side here. We have a tree sort of like growing right out of the rock here now. This, while not super important, all things considered, might look a little strange. So what we could do is we could actually paint this just like we have painted some of these areas that actually sit sort of like on top of the mesh, right? So I think we're gonna do that. I'm gonna see where that takes us. Did you all eat well? Well, thank you first of all thanks for asking. Today was a little bit of a crazy day. schedule wise. That's why I had to actually cut this into 2 pieces, because I was originally supposed to just have lots and lots of time for the stream, but we have a couple of kids and they had their sort of evening hobbies coming up, so and my wife was stuck at work, so today was a very unglorious can of pea soup. Turned out to be the dinner. So that's what sometimes happens when you have like maybe 15 minutes to feed your offspring, and then they're off to the next thing. Anyway, let's see. So we have this material here. This has this mysterious cliff material core node that looks like this. So we have the base cliff color. That's basically like this gray one here that has like a little bit of detail that you can see here, almost like scratches or something, but like not a whole lot. Then we have the depot level yellowish terrain color. That is this exact thing that we can paint here. And we can actually paint this thing in such a way that it gets a little bit of this sort of like ground pattern. This thing called the terrain pattern 512 darker. And the way we do this is that we paint into the red channel, so R. Color placement R applies grass. So this is like the, you know, the dry grass or whatever, this yellow stuff. And so color placement R, that means that we separate the color that comes into the color placement texture, separate them into red, green and blue, and based on that we feed them into different things. So red would be the grass, green would be this kind of dirt or whatever, darker brownish stuff. And then the blue is like has actually a couple of different levels. So if the blue channel has more than 0.25 in value, we apply this color. I think this actually look like they're basically exactly the same. Yeah, this is clearly something that I've sort of experimented with, that stuff, so we don't really need to think about that. But at least this grass and maybe even a little bit of this dirt, but we'll see if we get to that. So how do we do that then? Well, we go into texture paint and we paint a red valued, so this is the absolute red, FF0000, and we paint that into the color placement channel. And so this is what happens if we do that. We paint here, you can see that we actually get a little bit of, there's a little bit of well, texture, there's a little bit of pattern, darker spots. It's not a single colored yellow thing that appears here when we're painting this thing. If we look at the actual texture that we're painting though, it's all just a single red color. So this is what I said, or what I meant when I said earlier that this color placement is kind of like a mask. And if we paint the green, you can see that we're painting the green stuff here, but it actually appears as this sort of like brownish thing, right? So we can use this with some suitable, you know, fall-offs and strengths to apply just a very subtle amount of this stuff. Let's maybe do that even almost like a very sort of pinched curve there, and bring the level down as well to something pretty subtle. So the tree is growing from roughly from this position here. So we want to paint a little bit of this on top of this plateau. We just go and apply it here. That seems to be very little. Oh no, that was the wrong color. Red is what I want. Yeah. Yeah, this is a little too faint. And of course the nice thing about this is that like if we change the terrain color later on, we don't have to repaint this at all. We can keep the same sort of mask texture or whatever you want to call it. And then just come in here and go like, oh, I want it to be something completely different, right? Blender is making it difficult for me now. I can't undo that thing. Oh, Blender. The undo in this texture painting, I swear to God, this is like the most unreliable thing ever. Luckily, we have another one of these guys. We can copy that color out of there. So, it would be that one in hexadecimal. Let's go back to 21. There we go. But as you can see, you can actually toggle that color there kind of nicely. Oh, I have that still there. That's not great. Let's actually get rid of that. Image editor, paint. Let's get a complete black going here. And yeah, that should be fine. Texture painting, like overall, is something that I wish Blender was better at. And that includes everything from this sort of work where you're painting here in the viewport, as well as like, you know, filling things, right? You could do things like this where you select a few of these faces, select like those two maybe, and then you go and use fill, and only those faces, and you fill them, and you need to fill them with something sensible. What? That's not what I wanted. Terrain darker. Yep. Let's reload that one. Yeah, here's another thing that like, please Blender, would you not switch the texture here in this all the time? That's another workflow thing that I wish it did nicer. If you go like yellow, you can paint those two sort of faces yellow by filling them completely. However, if we look at the color placement, it's actually worked pretty well. Yeah, this actually worked perfectly. Sometimes you can see that it just like misses pixels. You just have black pixels here randomly. I don't exactly know how the filling works, but it seems to be a little wonky every now and then. Anyway, let's keep going with this now. How much do we actually want to paint here? We have this area. Maybe it should kind of come out here. What am I doing now? I have it set to red, I have it set to paintbrush. The texture is correct, but it's not painting. Again, one of these things where you're just like, what is wrong? What have I done? Oh, and what I have done is I still have that paint mask on, so that was actually just on me. Yeah, that's better. Okay. Anyway, please Blender people, put a little bit of, give the texture painting a little bit of love. Would you? I'm just basically trying out some things here. See if this makes sense. It might not make sense, but we'll see. And especially with the whole undo. See, now undo works perfectly fine. I can just paint and then I can undo. Sometimes it goes like oh, you want to undo, you know, some like selection of a texture somewhere that you did like half an hour ago, and you're like, no, I don't want to undo that. I want to undo the thing that I just did here in the view. So it's a little wonky sometimes. Right, something like that. How is this actually like? Yeah, there's not a whole lot of grass here nearby, so I don't think we'll necessarily want to completely like flood this area with grass. But I think over here we might want to do a little bit more strength. And we can of course even paint grass, like actual shell textured grass on this if we want to. Not that we necessarily do. That remains to be seen. What about this side here? We have some rocks here. Maybe these could go with a little bit of. Normally I actually do this painting there on my painting display, and it's a lot easier for a number of reasons, because like I have a 3D mouse, which is really nice and almost like a requirement for me when I paint. Because of course you don't have like a keyboard in front of you necessarily, and you don't have a mouse, and so for me it's super tricky to like navigate Blender without that 3D mouse. I think that's probably better without any. But yeah, it's really nice to use that, and I'm gonna used to painting like this, so now that I do it with like a mouse and keyboard, it's a little trickier, but I think we can manage. This. So that's okay. Now we can save this color placement. Now if we want to, we can go and paint a little bit of this like darker stuff as well. And we don't want to go completely crazy like we did there previously with this and paint it with like strength set to 1, but maybe this kind of slightly fainter paint would be nice. And quite often I'm just like following this sort of edges, right, everywhere. Following the edges everywhere, so that it almost looks like there's just like, you know, crap that's fallen onto, you know, dust blowing in the wind and then falling onto this thing. Just gives it a little bit more believability somehow, without even really being able to put your finger on why that is. And I'm not gonna spend a whole lot of time on this right now in this stream, because I'm gonna do like a paint overpass on the entire level when I'm kind of happy with the rest of it. That makes sense. Just a little bit of this. It can even be kind of like pretty sort of large scale. We don't have to try to paint any details or anything. Just like a little bit of, well, paint a little bit of believability into the cliff. Something like that, maybe. I think this is even like too small scale here. We need to make it larger. And then of course we can go in and just, what is this called? Smudge, right? No, smear. Not smudge, but smear. Smear it a little bit. If it doesn't look good otherwise. We can even, if we want to go a little bit more detailed, we can even pull it down, and that kind of makes it look like, you know, there's been some water or something, like sort of running down that side. Stuff like that. That can be kind of believable looking. You typically want to sort of pull it down in almost like world space. I don't want to make it too crazy though. Smear is also kind of good at just like nudging it back a little bit. If you've gone too hard on some of these things, just like pull it back a little bit. Can work really well for that as well. I think these crevices here should probably have more of the crap, right? It would have been like crap kind of pooling in those areas. If that makes sense. And again, we're not gonna do a whole lot on the backside because it's not really important. And normally I would probably have done like a couple of bakes already at this point, but as we saw in the first part of this stream, baking is a little wonky currently on this machine. It kind of manages it now that we lower the size of the textures for this particular cliff to 2K, but still it's not great. Which means that we probably won't do this other cliff in this stream because I'm gonna want to have larger textures for that probably. So like this guy here is a pretty large piece. I'm probably gonna want to have just to be safe. I'm gonna want to have 4K textures to work with for this one, and so yeah, probably not gonna do it on this stream now. I need to do it on my other machine, which has a slightly better GPU, not a whole lot better, but a slightly better GPU than this. Alright, let's do just a little bit more here in the right smack in the middle of this guy. Some of this crap. So green, yeah. Maybe it has like been sort of coming from this a little bit or something. Smear it a little bit. Smear and smudge. Adding weather details, yeah, a little bit something like that. Something like that, yeah. Yeah, that'll do. That'll do. And so, what do you say we save all the images, select that one, and then click bake and see what happens. It's again gonna take a while. So I'm gonna fly around here. This is gonna be a little slow now that we're baking at the same time, but like something like this is what I did over here. I actually put quite a lot of this like this yellow stuff on top of the cliff. That looked kind of okay. So I've sort of kept it in for now. Not 100% sure that's what we're gonna go with, but I think it looks kind of neat. Almost as if there's some like very, you know, small scale like moss or growth or something on that. Like at that height. So maybe that's something that I'll want to do, and I'll sort of do a paint over, like applying that kind of equally everywhere to some of these things. But we'll see. So that begs the question: what is the next step? What is the next thing that we're going to be working on here in this level? If we will leave this cliff here until later. I mean, I could always, in theory, we could do the setup, and then I could like even perhaps remotely do the baking. That might work. Yeah. That might work. Another thing that we could do is we could take a look. Oh, now it's clearly done because it's so smooth. Look at the smoothness. Here we go. So here's our baked thing. Boink. Here's the baked thing, and it looks pretty good. You can see it's a very subtle thing with this like weathering or whatever you want to call it. And there's the grass, all of that. It's a very subtle thing, but it does look pretty nice. So if we go here and we take a look here at the cliff, so you know, watch this space as I overwrite the image there with the new one. So boom. There we go. There's the difference. So yeah, I think it kind of ties together the terrain and the meshes pretty nicely in a way, when you can sort of paint this same color here out onto the cliffs. Oh yeah, maybe we should put a bit more of that yellow stuff on these, but I'll do them all in one go then when I start doing that. But that's kind of the idea. Is the baking progress shown at the bottom of Blender? It is, yeah, it is. It's shown here in a weird little text box. Or not a text box, but a progress bar, or whatever you want to call it. The problem, of course, is that like you can't really. Well, with experience, you can sort of interpret that in a way that that maybe you can get like some sort of use out of. But in my experience, it stays at like 0% for 5 minutes. And then it's at 1% for 1 minute, and then all the other percentages are in the final minute or something like that. Like, so you can sort of, when you know that, sort of proportionally. Okay, now it's jumped from 0 to 1, so now we're actually like in the last maybe 30% or something of the time. But yeah, it's really unreliable in that sense. Right, let's play this. Let's make sure we have the correct material and everything set up, which I think we should have, because I duplicated that cliff object type from another cliff, which had, you know, the proper ones set already previously. So this should be fine. Yes, you can drive on this. Actually, that might have been the other object. But this is definitely the correct cliff. And we got stuck. There we go. Yeah. Yeah, this is definitely the correct object, and we can drive on it, so we're good. And we got stuck. Just falling over, bending over backwards. And we got stuck. It's clearly not the car to actually like go here with. Okay. That would be that. So now I think we have like most of this area kind of done, except of course for that final cliff there. I'm gonna wonder if we should just do that after all, and then I'll just let my other machine bake it in the background or something. That might be worth it, maybe. If we don't do that, then I think the monorail might be kind of interesting to do. Or the tunnel. Like we need a gate here in this tunnel. And I haven't exactly decided how I want that gate to work and or look. But that might be something that we could look at. Like I'm sort of envisioning like a small sort of guard outpost or something here, because this thing is supposed to be sort of like the entrance to this quarry here, right? This basalt quarry, which is over here. And so there could be like a small guard post here, and then a sort of gate. How about that? And we have these small huts that we can just like plonk down whatever we want to, and I've been sort of considering them, even in the lore of the game, to be sort of like something that these guys kind of just like 3D print or something. One of these things. Of course, the terrain needs to be figured out. There could be like a small hut here. Maybe like a sign. Something. I don't know. Then there would be a gate. But of course the gate is the main thing here, because it's actually like it needs to be able to open and close and be blocking when it is closed and all of that. That's like an actual functional function. It has an actual function. And so how would a gate work here? Well, we can have two pieces of the gate like this, and then they can sort of split into and sort of disappear into the rock. That could be one way the gate could work. Another way the gate could work is something that I did previously, which I guess in some sense might be even kind of more more realistic to have in a place like this. It's here in this previous incarnation of the project that we looked at. If we just do post combat, just jumping forward in the mission script here. Hello, Just Coding Dev. What's up? Welcome to the stream. So here we have these kind of like garage doors, right? That are made up of these sort of slabs or whatever you want to call those. Like these pieces here, like all of them can essentially individually be moved around, but of course they kind of follow each other. So if I switch to this vehicle, you can now see the door is kind of opening up there, like a garage door. Well, because it is a garage. But of course we could use that or something like that in the tunnel as well. Right? That could be kind of interesting. And then the thing would just kind of like run up here in the ceiling or something. Or indeed or we can do what I did here in another level where we have a bunch of really large doors. Like if you fly over here, and again this is the build that you get to actually play, or this is the level that you get to play if you join the Discord. So do check that out if that's interesting. There's a pretty huge door. If we put a scale mannequin down here, like this, the guy is that large, and here's a door on the right. And here's a scout. But of course, you could have like huge doors like this that kind of just like go into the rock there on either side. That's another way. I wonder what would actually happen if we just used those doors for this whole thing. That could be kind of interesting. The problem with that, I think, is that currently those doors are probably part of that level's resource pack. So loading that door depot level, now it's refinery level specific if it is something, isn't it? You can't actually see it here. There we go, refinery. So it's that one, right? Bunker door left and bunker door right. Yeah, this thing is slightly too large for this place, but of course we could just take these guys and maybe scale them down, change their appearance a little bit, and use them here. That's just smart asset reuse. We don't have like a whole lot of space though. If we want to move it out, it starts poking through the cliff pretty quickly. But that might just be because like these things are just way too large currently. Yeah, they're way too large. Scale it down. Something like that. out of the way, so to speak. I think there's still... Are we poking through something now? No. Yeah, so we could easily fit doors of this size here without it really being an issue. So it's like 0.7 is the scale here now. That could be a thing. Of course, we're gonna have to add a little bit of a sort of I don't even know what to call. I don't know what the right word is here, but some sort of like fixture for these guys, so that they have you know, like maybe like a rail that they're running in, and then some sort of slot into the cliff there that they're sort of sliding in when they're opening, like this, whoop, and then whoop, and then you can drive through. Yeah, I think that's probably like the most sensible thing to do here. And it's just like it's just a linear, you know, animation to have them opening like this. It's very, very simple in that sense. Hey Caesar Salad, welcome to the stream. Welcome, welcome. There's a little bit of a gap here on the top, but I think that can probably be sort of remedied by having this fixture kind of cut this passage off here if we want it to be, you know, sort of tight in a sense. Yeah, I think that'll probably work. So the way I would probably do this then is by having these two as separate objects like this, then having the fixture, whatever you want to call it, be one, and then still having this sort of interior of the tunnel, this thing be yet one more. So you would have like 4 different ones, and in this interior would actually just have some openings here, some holes here that the fixture kind of like sits and fits into kind of nicely. Yeah, I think that would probably make sense. Hey, Aku. Good morning to you, sir. How's the promised land of Tampere? Went cycling and then it started raining. That sounds pretty much like here as well. Right. So what I think I'm gonna do right now is I'm gonna add a place for this entrance here. These guys are not gonna remain here, but I think they're gonna have to stay here for now because they're a pretty good start, and like the size is pretty nice and all of that. So let's add a new folder here that we call tunnel entrance, right? And then we move those guys over to it.
Oh, there were actually the E and V. So yeah, bunker door left and right. Quarry. And tunnel door entrance. It's right there. Let's go have a look at what that actually looks like. So this would be a blueprint from the refinery. This one. So this guy has a dynamic body transform, but it's set to kinematic. That's like the important part. That's why they don't sort of like just fall down as dynamic objects. Because they're kinematic ones, and then they have a mesh component, and that's it. Super basic. Okay. Yeah. Okay. And the nice thing about this is that if you make it like I have this bunker entrance, which those guys are actually sort of like originally supposed to fit into. This is way too large here for this. For this, of course, but like if we have this and we take one of these and slot it into place like this. So the entrance that we're gonna have to model here is gonna look something like this, right? And it looks a little weird from the outside because it has a bunch of these like back-facing faces here, right? We take that one and then we can add another one there. So here's our entrance. And then they kind of slide into this, and you know, these things don't actually even fit into this, right? But like the player's not gonna notice. Player looks at it from here and they can just see like, oh, okay, yeah, there's a slot there. But the nice thing about this, if we make it kind of like this, same kind of like entrance thingy that holds these things in place, is that we can model that now, and then come back to the like tunnel interior when I know how I want these sort of like tunnel walls to function. That makes sense. Which I think it probably does. Righty-o. And then there's some other stuff that we could maybe take from the refinery as well. I'm trying to find it here, or remember where it was. There was like a refinery entrance. It has like the hot and the boom barrier all in one. Okay, that's a little annoying. Yeah, I think I was just so very excited about getting that set up. So this is now very much kind of like made specifically for the refinery, but we actually have a small little hut like this with the boom barrier and everything. And that's of course, we could use this for this one as well if we wanted to. The boom is open and everything. This is maybe even more of a an entrance hut, like guard post sort of thing. So this might be kind of nice to have here, I guess. I think it actually fits pretty well, actually. We have grass growing inside of the house. Oh no. Oh no. Actually, how does this feel if we play this now? Just keep those just open enough that we can fit through. Nah, we don't need to save. actually might want to have a truck for this one. I will not test this out, but that's pretty neat. Might actually kind of work, especially if we tweak the ground here a little bit. Work nicer with this little hot guy here. Oh, that might be one issue to that plan. What if we turn off the grass for a bit, and then we go have a look. Where's the actual cliff? Yeah. Yeah, see, this is the cliff here. This is the terrain, this is the cliff. This part here, you can see the edge for the thing coming here. And of course this cliff, we can modify it, of course, but it's significantly trickier to modify that than to modify the terrain. And so that can be a little annoying. Just need to move this further forward. Okay, you know what I'm gonna do here actually, if I end up doing this, because this is not gonna be my first priority. If I end up doing this, these are actually part of the level refinery level specific back file. So what I will do is actually I will take them out of there, add them to a more generic back file, and separate these guys so that you can have this boom barrier open or closed, and this hot also separate from the rest. And then we can move the door somewhere else. So it doesn't need to be here on the back side. I think that's probably what's going to happen. But this is kind of nice. Might work nicely here from like a narrative and a environmental storytelling sort of view. And also we need more things like this that kind of like establishes the scale of things. How big these things are, how big this cliff is. Because if you don't have this, you have these ridiculously large doors. You can just think that like a person is that large, and you could go, yeah, that makes sense. The rest of the environment kind of fits kind of nicely. But of course that's not true, that like a person is actually this size. So yeah, I think we need more of these scale establishing things here as well. Undo until we get rid of that for now. There we go. And that one as well. Okay. So, maybe the next thing then is to save and close this cliff file for now. And I will do that last cliff on the other machine, where we can bake a bit easier. And then I will perhaps create a new quick mesh for this. We can start planning how this entrance will look here. So let's do let's go back here in quick mesh, and and we'll call this the tunnel entrance. Same as the parent folder, but that's completely fine. Yeah, maybe that's actually where it needs to be. It needs to be at the same transform as those gates, right? So let's do include surroundings. Maybe 30 is enough. 30 is quite enough. Then we open up another Blender instance and make it our Blender Sync instance. And here we go. This is the magic of Blender Sync. Just the fact that you can no, random is what I want. You can just take a piece of the level like this and just go, ta-da! This is what I want to work on right now. I do wonder if we should maybe hide these guys though. Hidden. Let's hide one of them actually. And now is the interesting part. Yes, it actually leaves out hidden things. It used to be a bug at some point where it just like it took everything. It even originally had the gizmos included. So it would show you these like arrows and everything here. Because the gizmo is just a normal mesh in the renderer, so it just basically used everything in the that the renderer was rendering, right? Now this thing should be like a mirror of itself, like it should be symmetrical along one axis. So maybe we'll just take that rotation. I'm gonna copy that into some text file somewhere. Like so, and then we can momentarily or temporarily remove the rotation. Like so. And then we can take all of that and remove the faces. And then we'll take the modifiers. We add a mirror modifier to it. Like so. And now I don't remember, but I think if we do that, it should still work. Yes, it does work. So we can take this back, and now if we basically let's move this down. So we want this sort of like rail that this thing runs in. These you know, eventual doors. We don't have any doors yet. Just have the copy of that other door there. But still, we want them to run in this kind of like a rail. And because of that, what's actually going on with that one? What are you? And what are you? Don't want you. All right. Okay. Yeah, we need to subdivide that guy. And move it up. No, move it up, not down. Move it to last. Then we take this thing. Add a face there. Actually, we don't need any of these faces. We'll take those faces completely away. That's fine. Right. And so now it's sort of like annoying. Okay, yeah, we have this thing, but like the ground is sort of spilling over here in some certain places, and then you can just go finish editing. And we go back to the editor. Here we have the thing, and it's what? Oh, that's right. There we go. Yeah, I assumed the transform of this guy, but they were actually scaled, so that's why it was wrong. But yeah, now it's back to 1, scale 1, 1, 1. So now we have it back here where it belongs. That's nice, and now we can jump between actually modifying this thing and just modifying the surrounding terrain very nicely and easily and quickly, like this. Magic of Blender Sync once again. I want to kind of fill it up so that this thing becomes a little bit of a pit, I think. Yeah, I kind of don't want there to be any sand inside of that thing. Okay, so that's one thing. So then what's the next thing that needs to happen for this to become a reality? Well, we need to cut holes into the side of this interior here, right? So if we go here and have a look at where's this thing actually situated, I'm gonna turn on the cavity rendering here, both, like so. So we have this guy, and we're gonna need to cut probably around, yeah, maybe there, another one maybe there. Right, so now we need to get rid of some of these surrounding things, but not all of them. Let's merge by distance. Blender does this funky thing, clear custom normal data. Right, so that one, hide that, hide that. Actually, we can even get completely rid of them, or at least separate them out to different objects, so that we can hide them separately from everything else while still being in edit mode. Right. Right, so we want this cut to be completely straight. So let's get rid of everything else. Now we have this one and this one. They need to be completely straight here, because that's where the doors will sort of slide in. how do we do that? Well, what if we take... Actually, we'll take the entire thing and rotate it. And that way we can then rotate it back by just zeroing out that rotation. Now if we take that and we set all of its right, okay, now I know. Let's take that point and we'll do active element and then 0 y or scale y 0. That gives us a very straight edge there. Then we'll do the same thing with this side. Scale y 0. Now of course we have some funkiness and wonkiness to deal with. That's funky and that's wonky. No, actually don't want that, we want the other one. That one. So like all of these other ones are just like going all every which way essentially. But we want this one to be straight. So that we can cut a straight hole into the wall so that the door can slide through. Alright. How deep is that actually? So if we have this guy here, we don't need to cut all the way, right? Nah, we don't need to cut that or that. But we do need to cut at least those 4. Just take them away. That's 1 slot, and then those 4. Yeah. That looks pretty neat. So now if we rotate it back, the thing fits nicely inside the hole there. We have another one here. Yep. This is not completely straight though. No, well we can fix that. That shouldn't be an issue. Yeah, I think I'm gonna finish that editing. We can see we need to rotate both of those and this one as well a little bit, so that it actually fits in that slot. Maybe that would be good. Yeah, I think that's probably good. And then we have a little bit of ground to clear here again. You can see sort of the resolution of the height map starting to become a little bit of an issue when you want to do this very sort of what should we call them? It's kind of small adjustments. The height map resolution might not be enough for all of those, but I think it's gonna be fine. Yeah, I think that's gonna work. I think we have actually... Yeah, we have some like terrain here. So that's stupid. We're gonna have to... If we want to actually make that slot here, where it kind of goes into the side, we're gonna have to make room for the door. For the door. I got lost. Where am I? Here we go. And just like with the previous level that I showed you, we don't need to necessarily have you know, enough room for this actual door mesh. If it's deep enough, you can sort of see that, okay, there's a slot here for this thing. It probably just goes in there, then that's good enough. Yeah, this probably makes sense to have here as well. Caesar Salad asks about the C interface generator you mentioned the other day. How fast does something like that run, and how hard was it to develop? Right, I can show you what I have. Just a second. It wasn't very hard to develop. I mean, you should see what I have before you get overly impressed. It's not. It wasn't hard to develop at all. Essentially, it's very basic code. The whole point of the generator is just that I don't have to write those interfaces by hand, right? And so that's not a problem, that it would be difficult. Regarding the speed, there's the bigger risk, shall we say, in that when you are working with an interface like that and you have a lot of function pointers, that is of course basically the same as having a virtual function call, right? You don't know beforehand what function is going to be run, so you need to evaluate the pointer and figure out what function is that pointer pointing at. And so that is not as fast as, you know, statically knowing beforehand at compile time or otherwise what function is going to be run, right? You can't inline a virtual function call. It always needs to be a function call, and it needs to figure out and then jump. So the speed is much more of an issue than just normally. But I mean, that is kind of that's kind of always going to be the case when you're calling like one language from another, because quite often you're calling like a DLL, maybe from another DLL or from the exe itself. That of course always means that you can't inline that call. As for how fast it runs, well, I've actually not really had any performance issues at all. But that is of course because I kind of stay in the engine DLL for most of the heavy lifting. So let me just show you that, because I know I promised you earlier that I would show it to you. So let's take a break with this and do a little bit of programming. I'm gonna go get a glass of water and then I can yap on. Alright, so close down a few things here. Let's see if this works. Let's go with Milton and just move over here. Now that does seem to work, but the size is very small. Right. So the way this system works is that you have the core engine, which is called basis. Basis.dll, right? This is the core engine. There's a video called The Anatomy of My Game Engine which explains this, but still. Just quickly show you this and talk over it. This is written in C++. Then you have the exe. If you're making a Zig-based game with basis, the exe is called trampoline.exe. And then my build system, if I make a published build, and like one of the last things that we do with this is we rename this to traction point.exe, but that's kind of how it works still. This is also written in C++. And then with traction point we have the actual Zig library, which is called means lib, I think, isn't it? I get unsure now that I'm actually writing this, but I think that's what it's called. Means lib. This is written in Zig, right? And so if we have a look here at means game. Means game is what it's actually called. Means game DLL. This is the Zig library. You have the trampoline, and you have the core library. Then you have some plugins that are loaded by this thing, but we don't really need to think about those here. There's no language changes or anything between those. How do I erase? Oh, the eraser is right there. Boop. Up. Yeah, so this was means game.dll. And the way this works is that this links to C++. It links normally to the C++ library, and then it loads. This guy load this means game DLL, and then this basis DLL wants to present all of the functionality that it can give this means game DLL. Because if you have a Zig component, right? You have a game component here. Game component here. It wants to call into this guy. Let's say like, mesh dot hide or whatever we want to call. That's a function call, mesh.hide. And the mesh is found here inside the basis DLL. Right? So this basis DLL actually presents like a whole list of things to the means game DLL. Here is my API that is Zig compatible. And so it pushes a bunch of function pointers to means game DLL, and one of these like function pointers might be like the mesh hide function pointer, right? That's kind of how it works. And this thing also has an API. This means game DLL has an API that is exported just normally. I'm going to show you all of this code. I'll just sort of quickly try to describe the whole system here. So this has an API of exported calls, and you have things like update calls that like this guy then calls using the API. So when the core engine thinks it's time to update or render a frame or something, it calls certain functions on this means game DLL, and the DLL can do whatever it wants. The trampoline also has a bunch of things that it wants to
advertise to this means game DLL, because the idea is that you shouldn't really have to make any like big changes to the trampoline if you make a Zig game in basis. You should just be able to write Zig most of the time, and everything should just work. But the trampoline has a few things that it also wants to kind of advertise to this thing. So this also has, you know, function pointers that it what the hell is that? PRT, function pointers that it wants to give. In addition to that, we also have things like Goofy. Goofy is the UI system, which is also a C++ library. It's not a DLL, it gets compiled into Trampoline. It's a static library. And we have things like Merlin, which is the particle system library. And we have Timbre, which is the sound library. And we have a few other things. We have Nemo, which is like the scripting things. And all of these guys also push their function pointers to the means game DLL, because they all want to advertise the things that they sort of have, and that the means game can call on them, right? So what does this look like in practice? Let's take like the smallest one, which I think is Timbre currently. Timbre has a few classes in C++. Let's go to event instance, for example. So the way you play a sound in Timbre is that you get an event description, sound manager, Timbre sound manager. Get event description by path. You give it a path. Hey, I know there's a sound at this path. I want an event description. Out of the event description, you can create one or more instances. You know, you want to play the sound 2 times simultaneously in different parts of the world. For example, you call create instance on that, and then you get an instance out of that. Then the instance can be started, and it can be paused, and it can be unpaused, and it can be stopped, and blah blah blah. You can set parameters on it and all of that. That's how you play sounds with Timbre. And all of these things, of course, are C++ classes. So we can't actually use these directly from Zig. So that's the instance. There's the event description, and then we have the sound manager. So the way this works is in something called a bind-a-lot file. So bind-a-lot is my name for this binding generator thingy that I have created. And this has a syntax that looks kind of like C++ a little bit, in that it has something called a class. But a class can be sort of like anything. It's more like a group of methods that you want to bind together. It can actually map to a class, and here you can see that it actually maps to the Timbre Sound Manager class, which is, you know, the same thing we have here, Timbre Sound Manager. And the Timbre Sound Manager has get master group bus. I think it actually exists here. No, it actually doesn't. I think it is probably master group bus probably maps to this get group bus function here with a name. But we have a get group bus which maps directly to that method, and we have a get event description maps directly to this thing, for example, right? And the idea here is that this is sort of like the IDL, interface definition language, for what should the API between Zig and C++ look like for this library, Timbre, the sound library. And this file is fed to the bind-a-lot binding generator. So if we look here, here's the file that we just looked at, the bind-a-lot one. We have a batch file. And the batch file, when we run this thing, currently it shouldn't really
do anything because we should have run this already. But we can see that we run this bind.exe. It's this little thing here, 26k. It's very small. And we give it as the input, the bind.lot file. We tell it to generate Timbre generated class bindings.h. We want it to generate source bindings generated types.zig, source bindings generated bind functions.zig, and source generated function pointers.zig. So 3 zig files. It's these three. These 3 files get generated, and then we also generate a header. So Timbre generated class bindings.h, which I think we can probably find here somewhere. It's not found actually in the project. It's just used from the Zig interop. Here we go, Timbre generated class bindings. And you can see this file was generated by bind.lot, the binding generator. And what it does here is that it creates type defs for all of these function pointers that we might want to actually call. So if we go back to the bind.lot file, look at it here. Actually, I'm just gonna rip it out of there to make it a bit easier to see these things at the same time. So get master group bus. Well, it gives us a basic Zig Timbre sound manager. So this string here comes from this class name here. Then get master group bus is of course that one, and then CB just means callback. And then we have one for group bus. That's this one. Get event description, that's this one, etc, etc, etc. So one of these type defs for each of the thing that we want to bind. And then it creates a binding function function pointer. So bind Timbre sound manager function. Again, that's just the word bind, and then that name comes from here, and then it's called function. And it takes all of those types that we wanted to expose to Zig, it takes as arguments, right? And then we repeat this same thing for all of the other things that we want to bind as well. So group bus is very simple. It just has 2 methods that we want to bind, and then it has a binding function. Event description has 3, so there's 3 function pointers and then a binding function. And event description is, event instance is the most complex one. So bind event instance function. Okay. Then we have something called Timbre Zig interop, and this is where the actual magic happens. So when someone calls, let's say they have an event instance in Zig, and they want to call release on it, because these things are reference counted. What will actually happen? Well, if we go to the bind.lot file, you will see here that this almost looks like C, right? Void release uint pointer CPP pointer. Looks like C. And the idea here with this bind.lot business is the fact that, like, once you've set up your interface like this, you can just copy all of this, copy paste it and copy paste it into here like that. And now you have, fully usable C sort of prototypes for all of the functions that you want to bind. You can see that this release one maps to that one, release when finished maps to that one, release after fade out maps to that one, etc. So I've just taken those and I just slightly renamed them to like event instance underscore, so that I know that is what we actually want. And the actual call to event instance release is just done like this. You reinterpret cast a pointer, so uint pointer t, into an actual event instance, and then you release it. Then you do whatever you want to do. You can see that basically all of these functions begin with this. It has the same thing. You get the CPP pointer, which is just a number, a uint pointer t, which is type def unsigned long here. We get that from Zig. But Zig doesn't know what it is. It just knows that it's a number that it's gotten from somewhere. And if it passes it back to C++, then it can be treated as an event instance. And then all of these calls begin by doing a reinterpret cast into the actual thing, event instance here. And then you can do whatever you want with them. So you can do pause, stop, set parameter, blah blah blah.
And so that's the idea of this bind a lot thing, is that like if you lay out your interface like this, if you feed this through the bind a lot generator and it succeeds, you know, you get this thing we already looked at, 0 errors, 0 warnings, then at that point you know, okay, the sort of glue code is written. Now I just need to take these guys and basically copy paste them here and then just fill in what they're actually supposed to do. And of course we got those binding functions. So if you search for this event instance send signal, where is it actually used? It's actually passed to this bind function that also got generated for us. And that means that even though this is sort of like unsafe in a way, because we're doing reinterpret casts and everything like that, because we're generating these type defs for everything, for the binding functions and also for these function pointers, you kind of have to like mess up pretty badly if you like accidentally get this to compile without like filling in all the necessary things, right? If we add like a void test unit pointer t cpp pointer int some number, right? We add this here, and then we build this. So we go back here to the batch file. We run this. You can see, okay, no warnings, no errors. And now we try to build this file. You can see that, oh, too few arguments to call, because now we're actually lacking that weird test thing that we just created. Which means that this is kind of nice in the sense that like you have to like mess up in a very specific way for the compiler to actually even build the thing anymore. That's like the C++ side. Hey Jake, welcome to the stream. Yeah, there's some WASM stuff here that I'm not gonna go all that deep into now, because it has to do with modding. I support both DLLs and actually WASM modules. Like if we go to this thing again, let's use another color here. You have this sort of main DLL library thing here. This one can be either a DLL file or a WASM module, which is going to come up kind of soon when we start talking about modding the game. But the point is that for a WASM module, you have to bind things in a different way, because you can't really pass like function pointers back and forth between a WASM module and a host system. You have to instead use this registering. But okay, yeah, and we can't open the trampoline exe because we actually have the editor running here, right? That's why it doesn't actually want to write the exe file now. It would work fine if we had that shut off. Right, so that's the Zig, that's the C side, C++ side. Then the Zig part of the whole thing, the whole business. When we build this bind a lot file, it goes in and it generates the bind functions. That's not the correct one. Let's go to the correct one here. So here we have bind timbre sound manager. Well, maybe we should actually start by looking at the types first. So again, we can see that, okay, this file was generated by Sir Bindelot, and if we look at like the same event instance release thing, we have it here, and this is just standard Zig. There's no magic about this at all. This is essentially the same as a type def. This is the syntax for a function pointer in Zig, so *const fn. And what I have done here, and what actually took a little bit of time to, you know, figure out and do correctly, is just the fact that, like, if you have a uint pointer t, for example, you need to have some sort of like mapping table. Okay, it needs to map to u64 on the Zig side. I also have some special interop types. I have an interop string, I have an interop vector tree, and there's some other things as well. There's nothing special about these other than the fact that they are marked as extern struct, so this thing here. This extern keyword guarantees that this follows the C API of the host system. And that is how you can just, you know, pass pointers to these guys back and forth, and you can be sure that they're writing them in a compatible way. So yeah, we have quite a few of these guys here. Right, so these would be the types. Then we have function pointers. So for the event instance, you know, we have this basic Zig event instance release CB. You can see that this follows the exact same naming convention as on the C++ side, but that's just kind of like that. It doesn't need to be that, but it is that currently. So this thing, we can find it here, and we can see that we actually have an instance of one of these function pointers. So it's a public variable event instance release. And when I said previously that the C++ DLL in this case, or exe, advertises everything it has to, you know, offer to the Zig side, what I mean is that it actually calls this, so Timbre Zig interop bind, it calls this function, and it goes through and calls all of these bind functions in turn and pushes a bunch of function pointers to it. So in this case, with the event instance release, it goes like, I'm going to bind the event instance now, and this is the function pointer that I want you, or this is the pointer to the function I want you to call when you want to release an event instance, right? That's essentially like what this does here. And so that pointer ends up getting stored in this pub var, in this generated function pointer Zig module, right? And it gets called through this. So here we have part of this standard API that I talked about, that this DLL needs to actually export function bind event instance, and again, all of this is just generated code. Here's that release pointer, and it just goes in and stores it in that place that we just looked at. So if we go to that release, we end up here where we just were, right? So that means that if you know the path to this guy, this event instance release function pointer here, you can release an event instance. But it's a little wonky to write code in this way, because like the underlying API in the C++ side is somewhat object oriented. It's a very old game engine after all. Wouldn't necessarily build it that way if I started today, but it is kind of just like the API style of this game engine. And because that is the case, I want the API on the Zig side to also be somewhat object-oriented. It's not an object-oriented language, so it won't be super object-oriented, but a little bit. And so, in addition to this is all now sitting in the bindings folder here. But if we go to event instance itself, we have it here. And this is how I wrap a C++ type. So since we can't just get an event instance pointer from C++, I can instead have a small struct which is called event instance and then ptr, like that. And it is basically like a wrapped event instance pointer in Zig. So it contains as its one and only member a CPP pointer, which is of type basis.cpp pointer. If you go have a look at what that is, well, it's just a U64, right? It doesn't really get any more complex than that. It's the U64 that we get passed to us from C++. And if this thing is a null pointer, well, then that means that, you know, the C++ pointer is 0. We shouldn't use this. So even though this isn't a pointer in Zig, it is to be treated as a pointer, and so you need to check for nulls and all of that in Zig code as well. And it has all of the same methods that were listed in the bindelot file, but they're just wrapped like this. So release just calls tamber.bindings.api.event_instance release CPP pointer. And that means that you can call, you know, if you have, I'm just gonna write in comments here, if you have like const event which is, you know, of type event instance ptr is something, then you can just do evt.release, you know, and this is now the call that goes through this function down into the function pointer and back to C++. Now there's one more sort of wrinkle to the whole thing. You might be wondering, okay, what was this API thing here? And this is, again, this has to do with the WebAssembly, because with WebAssembly these calls need to be routed slightly differently. So if we go and have a look here actually at this event instance underscore release, you can see that this is a comp time if statement. So depending on if you are actually compiling this thing as a WASM module or not, we either run this event instance release WASM, or this is the actual function pointer that we looked at earlier. If we go click here again, we end up here where the pointer was stored. But this is WASM thing is basis build options build as WASM. This is set when you're building the actual library, and not all of these are necessarily available as WASM things, in which case you just have like a compiler error if you try to use one of them. So that's kind of how it works. So, you know, if we go have a look at some actual code that uses this thing, let's do let's see. Right here. So here we have event description. Event description is here. It's assigned here. Well, first of all, it is found here. It's a Tamber event description pointer, and oh, that's not how I do it anymore these days. I just do it .null like this. So event description is a Tamber.event description pointer ptr. Again, this is one of those wrapped types. If we are on the client, then we ask the sound manager get event description. Well, this is the first time we're gonna go into the API get event description. I'm gonna go here, and we're gonna end up in one of these function pointers, right? So the first call to C++. We're gonna get a cpp pointer out of that, which is uint64, and we init the wrapper with that cpp pointer. So that gives us the event description. Then we can use the event description here to create an instance. Create instance. Again, here you can see Timber Bandings API. Here again we're digging into the C++ side. Create instance, and again we're going to end up with one of these function pointers. And then we initialize that again with the same thing. And then we have the event instance, and then we can call event instance start on it. And again we go into the API. Event instance start, and we end up here. And of course, event instance start, if we go back to the C++ side, lands us here, and we do a reinterpret cast, and then we call start on that. Right? So what am I trying to show you here? This is what you will have to handwrite, unless you just want to use these function pointers directly, which is of course completely fine. But this function here, this start function, this pause function, this stop function, this is what you typically want to handwrite on the Zig side. This is not something that Bindelot gives you. And of course this allows you to you know, convert the data into such a form that the C++ can read it. For example, if we go to Sound Manager and we want to get an event description by a path, you can see that we take the path here as a const slice to a U8, which is like the idiomatic string in Zig. But C++ doesn't understand any slices. It wants pointers and lengths. So I have this thing called the interrupt string, which I turn this path, which can be a literal or it can come from some other string or something, but I turn it into an interrupt path, and an interrupt string, sorry. And an interrupt string is really just, it's a pointer, that's right here, a pointer and a length. So it's essentially like a slice, but it's just more explicit. I turn it into that, and then I pass the pointer to that slice instead of passing the slice itself, right? And again, this is one of these things that I've written myself rather than having Bindelot generated for me. So that's kind of the gist of it. I hope you sort of were able to follow along. I hope this wasn't too complicated. So of course, just like making the Bindelot system itself is kind of like only the beginning. That's not super hard. What is difficult here is making the API in such a way that like it is performant, it is robust enough. You don't run into like null pointer issues and things like that all the time. But actually just making the generator is not difficult at all. Now of course I can show you the code for Bindelot as well if you want to look at it. I'm not sure it's all that interesting, but we can look at that as well if you want to. I'm just thinking, is there something else here to kind of really demonstrate? But yeah, these kind of wrapped functions are used pretty much all over the place, unfortunately, one might say. These days I try to move more and more things just over to Zig that can be in Zig, because it means less jumping over the boundaries between this guy and this guy and then the game itself. It's a lot of pointers, absolutely, yeah. There's a fair bit of pointer chasing, but that can't really be avoided, I think, if you want to do DLLs. I mean, to be fair, this is not that much worse than if you're just using a C++ library from a C++ program, and that C++ library happens to be in a DLL, right? So consider Vulkan or OpenGL or something like that. The classical OpenGL, what is it called? Like extension wrangler or whatever it's called. And I think there's a slightly similar mechanism in Vulkan where you get like the pointers, the Vulkan functionality is brought into your game or app as a bunch of function pointers, right? And I think that's how OpenGL works as well. And you get those by name, and there are a bunch of helper libraries to like help you figure out if things are present or whatever. But still, you're going to be calling all of those OpenGL or Vulkan calls through function pointers, and it's kind of like the same deal here. And a whole bunch of apps and libraries use OpenGL and Vulkan, and they seem to be doing quite fine. So, like, I don't think you should necessarily freak out all that much about using function pointers for functionality. Also, yes, I would like to see what binder looks like. I can show you. Yeah, it's kind of horrible code actually. Let's see what we have. It's in my tools solution, which just takes like half a minute to open because it has so many freaking projects. Let's see. Bindload is actually very small itself. See, we even have a Rust writer from a few years ago when I was experimenting with that. That never really took off. Let's close all tabs. So we have the main program, which looks like this. We're taking those inputs. So yeah. We have the input, which is the binderlot file. We have the output, which is the C header, and then we have those three Zig files that we looked at: the generator types, bind functions, and function pointers. Binding API is a thing that I almost never use. I used it basically once, and it generated something like 20,000 lines of Zig for me when I was doing the WASM integration for the first time. And after that, I haven't really used it for much. It basically generated. Let's see if we can find it. Like the binding for the core engine is obviously much larger. It generated this. Oh, okay, yeah, this is actually not one of the really big ones. Yeah, never mind. I think the API is quite large. The API is like 6,000 lines. Yeah, here you can see that like I haven't exposed all of the API to WASM yet, nor will I necessarily ever do that. But like AngelScript utils set color ref out. If you try to call that from a WASM module, you just get a compile error that like AngelScript utils is not implemented for WASM yet. But yeah, anyway, that's the input. Then we have some crap here. Yeah, we do some more handling of input parameters. Then there is a let's see, parse header information, class parser. So I think this is the code that just goes through and figures out the binderlot syntax itself. So you know, basically this thing that we looked at. So we have some directives here. Zig root module is basis, Zig function pointer path, basis.bindings.generated function pointers. It's kind of like just like where do you want the function pointers to be placed, and it's this basis.bindings.generated function pointers, which gets essentially like they get prefixed by this guy, and then the generated type path they get prefixed by this thing. And then you have a parser that understands enough of basic C to be able to parse this sort of thing. So you have a class, and then you have you know, return value, name, and then a number of parameters, and that's essentially it. And I think that's basically what this thing does here. So you know, you're inside a class, end the class. We deal with comments. Try to parse the method. Just completely self-written hacky parser for this sort of thing. Parse the parameters, and then we just add them to like the list, and then we add all the methods to the current class. And yep, that's it. Right. Here's something that I had at some point, because like Zig has been unstable, and it's still unstable, and it has been even more unstable at some point. And there was an issue with like returning booleans at some point. This has most likely been fixed, you know, ages and ages ago. But there was an issue. You can see here
Having constant bool values in Zig and passing them as is to C++ causes weird issue where true would yield the value 255 and false would yield the value 254. So I just had like a hack where like we use an int bool, so it's a boolean represented as an int instead of just like normal bools. Things like that. So that's a parser, and that gives us a list of classes. And a class is a small, well, class that has a name and a bunch of methods. And a method is also a small class that has a name, a return type, and a parameter. You can see we're just using strings here. There's nothing special about it in that sense. And a parameter has a name and a type, and that's it. And then we have the header information, which is this like that stuff. Okay, so now we've parsed the thing. So we have header information and we have a number of classes, and then just C writer and Zig writer, and that's basically it. We just write some output here at the end. So the C writer just writes that header we looked at. So basically like this guy, for example. So for Timbre Sound Manager, we have generate all of that. And the code for that looks like this. So for all the classes, we write a comment about it, write the method callback type defs, and then the binding function pointer type def. So type defs for the methods, type def for the bind function. Super simple. We don't need to look at the Rust writer because that's not used and probably doesn't even work. But here is actually, this is perhaps like the most interesting point of the whole code, I think. So here's that mapping table that I talked about previously. You're gonna want to have a mapping table if you're working with different languages for like how to map certain things to like the most suitable data type on the other side. So uint pointers are mapped to U64s. Const uint pointers are mapped to, this is a Zig syntax for a C pointer to a const U64. And then we have a mutable pointer T pointer. That's kind of like a double pointer. Becomes a C compatible U64, and so on and so on. So this is kind of like, you need to figure out how to map these things properly. Otherwise you're gonna run into issues. But it's basically just like all of the primitive types, right? Then we generate the imports. What does that mean? I don't even remember. Let's go have a look here at the generate the function point. Right, so it's that one basically. Const basis. It's like, where do we get the basis namespace from? Convert data types. And here we have actually like, yeah, so convert data type actually uses this data type mappings. Data type mappings is this table we looked at earlier. And first we check if we have any handwritten custom data mappings to use. If no mappings were found, we use the type name as is, prefixed by the namespace in which interrupt types are kept in Zig, and correct pointers to Zig syntax. So it's just like, if you give it like a thing pointer, it tries to generate a thing on the Zig side, right? So if we go here, I'm gonna move that out of the way. And let's do like a... Let's go back to Timbre. Timbre is nice and small. You know, we do this, we do void do thing. And then again we give it a uint pointer t. That's sort of, it's almost like a convention if you're wrapping a method specifically, you're gonna always want to do this uint pointer t, because of course in C++ this pointer is like hidden from you, right? Right, but now if we just take like const thing, thing, right? We do that, and then we go and run that thing. So we don't get any errors, because like bind-a-lot doesn't do any type checking. It just, you know, it trusts us that we know what we're talking about. So on the C side, this is what happens. We get a new type def here with a const thing pointer, and it's also added to the bind function. And then on the Zig side, we can see here. Can I make this larger somehow? No, I can't, but you can probably see here. So we get a C pointer to a const basis.bindings.thing. So that's where you would want to put your thing type, so that, you know, this would actually compile, right? Same thing here. Well, you don't see any you know, parameters there. And neither do you do it here, but yeah, you get the idea. So it's pretty flexible in the sense that like you don't need to go in and modify bind-a-lot every time you add a new something to your API. It kind of just like tries to do the right thing and guess what you want. So that's convert data type. Then we convert parameters. That's typically super easy because the syntax is just the same. Actually, it's not super. It's not necessarily that easy, because yeah, we need to convert the data types here. Yeah. Never mind. And then yeah, it's just writing those things out. It's not super impressive, I guess. It's basically just like filling in a string with some headers, and then iterating over all the classes and writing some stuff for each class, and then just writing all text to a file path. Same thing with function pointers. The binding API is a little more complex, but yeah, this is almost never used. And that's it. That's everything. That's everything there is. And then every library on the Zig side has, well, every library that communicates with C has this C API folder. It contains the bind-a-lot.exe itself, as well as the DLLs that bind-a-lot.exe uses. Those guys. It contains the bind-a-lot file and a batch file to generate its bindings, and then the header file, which is also put there. And then so that's timbre. If we go to Goofy, you can see it's exactly the same thing. Go to Trampoline, you can see that's exactly the same thing. Basis, of course, this is the large one. This has a few more things actually. Yeah, this has a few more things. This has some type defs for because the core engine library, this guy, basis DLL here, this guy is gonna call a bunch of things every frame or every update, such things like update, and when like a well, let's see what we have here. I can't think of anything right now.
when the core engine library wants to create a new game object and that game object has Zig functions in it, it's going to call new component function, right? And then when that goes away, it's going to call delete component function. So this guy actually has type defs for those exported functions. Exported is the correct term here. So C factory component function takes a uint pointer, interrupt typed pointer, and a bool. I think if we search for that, we should find. Yep, here we go. C factory new component takes a uint pointer, which is an int pointer 64, an interrupt type pointer, and a boolean. And this is sort of like the exported API from the DLL. So yeah, that's it. And we have quite a few of these exported things that the engine kind of expects the game DLL to have. So yeah, thanks for showing it. No problem, no problem. So it's not a tricky system. It's not a very complicated system, but of course, like, the devil is in the details. There are some slightly hairy things that, like, you need to figure out, things that, like, don't necessarily make themselves known until you've used this thing for like half a year or something. But yeah, I'm quite happy with how this works. And the nice thing is that, like, it seems that there's like so many different things here that can go wrong, right? Or actually, rather, there's so many different things to change here, right? If you want to expose one new method, like, you have to touch so many different things and files and everything, and like, how can you ever do this? It's actually not really true. If you want to expose a new method, it's actually super simple. If you want to expose a new type, it's a little more tricky. But we're talking about like maybe modifying 5 more lines or something like that. But just like if you want to, let's go back here. Let's just add something that would actually work. So we can do like do thing, and just add this pointer here. We want to expose one new method like this. You just add it here, and you build the thing like so. Then we copy that out of there, just like I mentioned previously that you can do, and you should do even. You can already see here that Visual Studio is giving us a red box there that you're missing something. So let's put it here, event instance do thing. And now we add it here, and the problem goes away. And then we can do this thing that we do in almost every single thing, and then ebt dot, there's no do thing here obviously, but we can do something, get state, whatever. So now we've sort of implemented the C++ side. Now the only thing we need to do here is go into event instance pointer, pub fn do thing, self const self void, and here we can already do timbre bindings fp event instance do thing is right there, boom, and then we pass the self cpp pointer to it. That's it. Now it's bound. So it's actually kind of simple because the bind lot generator does all of the type checking and the glue code generation there in the middle, the thing that you're most likely to mess up
that. Let's undo that. The devil is always in details. Absolutely. That's where the devil typically hangs around, in the details. In the deeds. Coolio. I think that was the binding system in a nutshell. So maybe we should go back to Blender and try to figure out this thing. In some ways, this is much trickier. Whoop, that's not what I wanted. You know, in the end, for someone like me, like making the engine is the easy part, and making the game is the tricky part. And it seems to be the case with many other people as well. Right, I think that's probably enough digging. Oh, not depth of field, but what is it I want? I want cavity. There we go. Both. Rightio. So it would be kind of nice to have some sort of what should I call it? Let's take that and zero it out, and then we take this one and we do the opposite here, so we get them sort of nicely sort of world space oriented here in Blender. I think I want some sort of like arch here, actually. So let's do like a let's add a cylinder, and we rotate the cylinder around X 90. Oh, that's location. That's not what we want. Rotation. There we go. And then the radius. Let's bring up the radius. Quite a lot. Does that make sense? Is that maybe too much? That might be a little too much. Yep. Yep, I think it's gonna be good. Actually, which side? Yeah, it's that side, so it's the correct side here. I'm gonna show you what I'm thinking just in a sec, or it's gonna be obvious to you in a sec. There we go. So let's move that out of the way. Cut that up. Cut that up. Yep. I think actually we want those as well to be gone.
It's almost as if this thing is not really centered now. Let's submit this now, or not submit, but like let's go back to the level and move this so that it's centered in the middle of this tunnel, somewhere around maybe there. That looks better. The game is the hard part. Yes. Yes. Jake knows what I'm talking about. So if you grab that, whoop. Yeah, Jake is making a pirate game that you should all go and play. Oh, actually, it's not. No, sorry, Jake. The game is not publicly available yet, but you should all go wishlist it. Is what I'm trying to say. You should all go wishlist the game. Let's see. Which way does that actually go? It's probably like the wrong orientation, isn't it? Yes. Flip normals. Like so, and then we can extrude that out to the middle. But I need to have vertex snapping on. Something like that, right? We're gonna need to have a sort of a slot there in the middle of this thing for the actual door. Let's maybe put that in right now. Scale Y. No, okay. Here we go. There's the Y I know and love. Something like that. Right. And maybe we should even scale this a little bit down. Like I'm envisioning some sort of concrete sort of, I don't know what to call this. I don't know what this would be like in proper English. This kind of construction, but like kind of like the I'm drawing a blank here. Kind of like the sort of fixture that is you know, somehow kind of like I don't know how to explain this. I need to think about it a little bit. Way too difficult, especially when I'm modeling at the same time. Like if you're building some sort of structure like this, you kind of you dig out the the space for the doors to occupy when the gate is open, and then you sort of make sort of like a nicer sort of like surface on top of that, using like concrete or something like that.
And I don't quite know what that this structure would actually be called. That's my crisis here. Also, maybe we want to take that away. Do something like that, maybe. And then just merge all of these things. I guess these can just be like a fan like this. Something like that. And that gives us this kind of nice looking gate feeling, and then that thing can just go all the way to the top. Yeah, that's gonna work. All right, so what's going on here with the... Yeah, that's actually the center. Okay, just the... It's just the perspective throwing me off here. Cool. Yeah, I'm not really a fan of this topography here now. We're gonna have to figure something out with this because we have some super thin super thin polygons here. That's not nice. Let's get rid of those, probably. Dissolve the edges. 1, 2, 3. Dissolve edges. Right. Yeah, that looks better. So, I mean, I'm not done yet, but that looks better already. Something like that, and then we can join those together instead. Yep. And like, I don't think we need actually these guys for anything. Up. Faces. Faces. Take away the faces. We don't need those either. We can just make that kind of collapse like that. Even... maybe even that one. Yeah, that's probably good. And then what is this? What is this? We don't need those at all. Bye. Almost like losing my voice a little bit here. Okay. That took like way too long to make. It's such a simple shape after all, but whatever. We have it now. We don't need the bottom for anything, so let's get rid of the bottom. Faces. There we go. Does it reach all the way up? It does not. But that's fine. We can just extend it upwards. Something like that, and now of course we are approaching the thing here with some pretty nasty thin triangles here on this side instead. So maybe we'll just do a quick little fixeroo here. Oh yeah, I need things here as well. Right. That instead. Kind of seems more natural that way. Yeah, that makes more sense. Okay. How about now? Oh, up. That's not what I wanted to do at all, actually. Yeah, now it reaches all the way up.
up to the top. We might want to perhaps make it ever so slightly higher still, because if that tunnel changes, then we don't want to run out of concrete slab there, right? That's kind of nice looking. Actually, maybe what I want to do here is just apply that. Maybe so we can get rid of some of these things here in the middle. And the nice thing about this is that I can always get it re-centered or get it to have no rotation then for the final mesh by just setting that to 0. Again, one of Blender Sync's magic abilities to copy the rotation from the object there. Okay, so that looks nice. Of course, we have a bit of a gap here, of course, but that I don't think that really matters at all. We also have a gap here under this one. That should be completely fine. So how much do we actually need to open these things then? Let's set a movement snap to something like 3. That would be 6. Yeah, I think 6 is probably quite enough. Doesn't need to open all the way. I think the largest vehicle that we will need to run through this for the mission is the gripper truck. And look at that, the doors actually even fit here. Yeah, and the gripper truck is not a very large vehicle. Fits through this, no problem whatsoever. You can have a whole lot of cargo in the back of the gripper truck and it will still fit. That's nice. Okay, so far so good. Let's make that some other blockout color in the meantime. Let's make it maybe brick color. And just kind of drive to it and see how big it feels. It's probably pretty big. Yep, it's pretty big, but it's not, I don't think it's too big, which is also nice. It just looks proper big. Maybe we can move this thing and move it very slightly to the right there. Like I'm not sure how that tunnel is going to change actually, but it kind of just looked a little bit kind of off center there. Now it looks off center on this side, but again, thanks to the magic of Blender Sync, we can just do this. Oh, look at that! Yeah, we have a problem. We have a problemo. Gonna have to fix that. Yeah, that concrete slab needs to be a little wider, and that's actually good because I thought it looked a little too I don't know, flimsy compared to the doors. It's definitely not flimsy otherwise, but compared to the doors, kind of just like, I think it needed a little something, and I was gonna get it. So finish that, and then we take that and we edit in Blender. And that means that, like, basically, yeah, I think we're gonna want to take all of these, all of those, and extrude them a little bit. And how much? Maybe 0.35. And then we'll take this side and do the same thing with it. Whoops. Extrude 0.35, like so. And yeah, we don't want these guys. We don't want to have. Get rid of the faces. Yeah, regarding the difficulty in just making the game, it's kind of interesting how difficult it sometimes can feel to just work on the game. Like this thing that I'm making right now. I think I mentioned this thing like probably like almost half a year ago now. That oh yeah, I need to make an entrance here and there. I need to make like a gate here in the tunnel, right? I think it's been like half a year since I mentioned that first time or something like that. And it would have sort of made sense to just do it many times, but for some reason it just like occasionally just like it's so difficult to do. Just do things that you want to do instead. Even though you know from like a slightly detached perspective, you know that like, okay, for this game to actually progress, you're gonna have to do these things now that are kind of boring, not necessarily flashy, not necessarily interesting from either an artistic perspective or a technical perspective, but you just need them to be done so that the game can happen. And still you don't. You just go, nah, I better work on this other thing. It's more interesting, but doesn't really do anything for the game. Well, that's not true. Not most things that I work on do something for the game, but still, get the point. It's annoying. It's annoying is what it is. Actually, we're gonna need to have end pieces to this thing. It's now something I'm realizing here. Let's have that. And then we're gonna want to actually drive over this thing, because this thing is gonna have collisions. Yeah, this is actually good. I'm gonna have to fix a few things here. Let's add like a face there. Add a face there. So we actually have end pieces. The door can just pass through them. It doesn't matter. But then we're gonna want to have. Let's see. Let's split that. And then let's do the same thing here. Just like in real life, we don't want this threshold here to be too hard on the vehicles, right? Kind of want this to be a little more smooth. Now I'm actually realizing I probably don't need these these splits here. I can just do this. I can take these 4 edges and just bring them down like so. And then I can fill in this. Like so. Same thing here. And I think we're gonna want to make those sharp. Mark sharp. Like so. And then we do UV project. Finish. Right? I think so. Yeah, annoyingly, like raising this ever so slightly just means that we get a little bit of stuff there inside of that as well. And that just has to do with the fact that like the height maps, the resolution of the height map is not quite enough, right? So what we'll do instead is we'll go back here and I'm gonna edit that one more time. We're gonna add a little bit of an outcropping here to it. So let's do like extrude maybe 0.5 and extrude 0.5. Then we'll take these, actually those as well, just move them back up a little bit. So that we get a smoother slope there. Right. Maybe I even want to do a bit more, just in the same direction, same angle, just a bit more. Let's do just that one for now, 0.5. And then just bring these guys in. And then we can actually remove those completely. Let's hide those once again. Let's see if we can't figure this out. Oh, actually, I have so much strength here that I might do unnecessarily. Might take away some of it unnecessarily. Let's be a bit more careful with this. There can be a little bit of ground in that. That's not a problem. So this thing that we're seeing here is actually, I think, part of the interior of the tunnel. So we're gonna want to lower that. Smooth this out a little bit. And then we're gonna have to make sure that we can actually drive on this, like, you know, at high speed. Once this thing is open, once this gate is open, should be able to drive on this at high speed with the Scout. Without, you know, making somersaults or something after after hitting that with your wheels. So, what do you guys think? Is this fun content? Watching someone make small adjustments over and over, tweaking something. Is this fun content? Is there something more interesting I could maybe stream? This stream in particular has been just basically like, right, I need to work on the game. I need to work on this particular part of the game. Might as well do it on stream. But my idea of like, might as well do it on stream actually has more to do with like, is it something I can actually, you know, sensibly make on stream and have it be somewhat decent quality, rather than actually thinking about it like, from the perspective of, is this actually fun or not? So, you know, I'm fully aware this might not be the most riveting content. That's, I guess, what game development is like. Like, my favorite stuff is like a healthy mix of a lot of things. I do agree with Jake that Blender stuff tends to work kind of okay on stream. My favorite thing to stream, I'm not sure if that's the people's favorite thing to watch. My favorite thing to stream would be like making a whole feature, right? So making something where you like model a little bit. Let's say like we made like, this is not something I could ever necessarily build on one stream, but let's say we made like a new crane for the mother vehicle. That would involve modeling, game design, programming, probably like texturing, maybe even like audio and particles and things like that. That's nice if there's a healthy mix of all kinds of things. Let's move those to the side, like so. So now if we make this physics type, set it to try mesh, and we set the physics material name to default ground. We should be able to drive over it with the Scout. Let's make sure that's actually possible. People seem to stop watching my stream when I have too much code on the screen. Trying to think if I've run into the same thing. Okay, let's see. Can I drive over this now just easily? Yeah, you can hear the suspension just go like boom when you drive over it. That's probably not a problem per se. You can of course like make the collision be different, distinct from the visuals. Yeah, like it kind of like jumps a little bit, and that of course has to do with that age-old thing of the tire model being a little wonky. But we can definitely make that less harsh. because those doors will be kinematic, and that just means that they don't really care about being pushed around. So even if we have like a little bit of physics intersecting here, it really doesn't matter at all. Actually, let's take that away and extrude 0.1, 0.2. Let's go with 0.2. Extrude 0.2. And then just turn that into a little bit of a slope. Right? Is that good, or should it go all the way in there? I think it actually probably should go all the way in there. Yeah. Let's do that instead. And that we can actually do probably just by taking these and scaling like so. That's just the easiest way to do it. Yeah, that should be good. Let's go with that. Yeah, that should be less less harsh on the tire model. Yeah, about people stopping to watch when you have too much code on the screen. I'm gonna tell you a secret. I might have mentioned this before. Some point, I don't remember. But the fact is that I seem to have a lot of subscribers that don't like it when I stream. Yeah, that's a little nicer maybe. Every time I stream, well, not every time, but usually when I stream, I end up with less subscribers than I had before. Right? If I make a new video, that's typically a net positive for my subscriber count. But if I stream, it's quite often a negative. Then, of course, I haven't tracked the numbers. Might be that like later on someone finds my stream, because my streams are actually like mostly watched after the fact. Or at least like, you know, as much as during the stream. So it might be that like later on they kind of gain back a few new viewers thanks to the VODs being there and all of that, but like I typically just lose people when I stream. During the stream or right after. After the stream I go and see, oh, did I get any like comments or anything or something like that, and I just go, oh, okay, I lost like 3 people again. And then I just shut up for a few days and I gain them back. Streams are fun though. Yeah, thank you. I'm glad they're fun. Yeah, I'm not gonna stop streaming. I'm not gonna stop making videos. I've said for the longest time that I kind of don't even consider myself a YouTuber. I guess that's to some extent that's not true. But I'm just much more of a game dev that happens to put stuff on YouTube than like a YouTuber.
making a game. And YouTube is just sort of like, well, it's a good way to connect with people and do a little bit of marketing at the side. So it's definitely been a positive for the project. But yeah, I'm not super sort of concerned with viewer counts. I'm much more concerned with people just knowing about the game, but those are of course linked. There's no way around it. I think this thing is actually unnecessarily deep currently. You see even the wheels here. Even though we're not gonna use exactly these doors, we're probably gonna use a version of them. And the wheels don't currently even reach the floor there, so let's just bring that up a little bit. My first one, but I've enjoyed it. Well, thank you. It's fun. It's fun to hear. And yeah, don't be worried if you're thinking I'm gonna stop streaming. This has been like my knowledge for a long time that like, yeah, I just lose people when I stream. That's just how it is. And of course, you guys who typically show up to these things and actually even write some comments and things like that, even either here or later on Discord, stuff like that, you guys seem to like these things, but I think it's pretty clear that not everyone does it. Some people just want me to show the game or, you know, make web GPU videos or something. Okay, that's probably better. A bit more still. I'll gladly raise that because I kind of don't want it to be too deep. Something like that, maybe. People who watch the streams are the most engaged. Yeah, well, that should be kind of obvious, I guess. Though I do get a lot of views during the like maybe 12 hours after the stream or something. I do get a lot of views. Maybe even like 24 hours after the stream. And rare is the occasion when someone actually comments after the stream. That almost never happens. But it does happen every now and then. Okay, I think that's probably what we're gonna go with. Let's drive over that and see how it feels. Yeah, that's nice. What's the purple view in Blender? Just the sharp edges. That's the sharp edge overlay. Quite simply. You can find it if we go. Let's go back to this guy. You can find it here in the. Oh no, we can find it. Where can you find it? Right, this changes after the
There we go. So sharp, here. Display sharp edges. Clickety poo. You have the same for the seams, as I'm sure you know. Seams show up in red. Yeah, you need to be in, I think. Okay, you don't need to be in edge mode, but you just need to be in edit mode for that to show up. Yeah. I mean, where them show white. What? Ah, okay. You mean, yeah. You mean the cavity. Cavity is right here. Boom. Yeah, now it's off. Yeah, it's here in the viewport shading. Cavity. You can set it to world, which kind of tends to like darken these crevices more than anything. And then you can set it to screen, which is this is probably what you want. You want this sharp edge here to be slightly sort of like highlighted. It's almost like the edge highlighting that I have going here with my art style, and then you can do both at the same time. Yeah, I just use it because like every now and then you have, if you don't have it on, sometimes it can be tricky to like here, for example, like you're just like what is going on, like you can sort of see that there's a little bit of intersection there. Then you turn it on, cavity rendering, and it shows it very well. Sometimes though the screen one gives you quite a bit of artifacting, like you can see here. I'm hoping this comes through on the stream. You can see this kind of stair-stepping effect that happens here. If that is the case, then you might want to turn off the whole thing, or then just use only world. Oh, it's world, is it? Yeah, okay, it's the world one, which now and then gets a little artifacty. So then you might just want to do screen. Yeah. That's that. Coolio. Okay. That's excellent. Maybe I'll do the doors still today. And then maybe think about calling it a night. Let's see. Haha. Right, so I have. Here's what I spoke about. Yeah, I've lost 2 guys today. Probably see. Yeah, you can see we started with 4,508, and now we're down to 6. Yep. It's like clockwork. Yep, well, as long as I get my job done and you people get some enjoyment out of it, then I'm happy. Okay, so I was thinking we would maybe just take this door, scale it down to 0.7, and use that as the base for the door here. Wouldn't worry about 2 to 3 subs. I don't worry. Don't. Yeah, you shouldn't take it as me worrying. It's just I find it funny rather than anything else, that like every time I stream I lose a few people. It just shows that like maybe, I don't know, maybe my videos that are actually getting like a lot of views and that bring people in are so different than these streams, that people go like, what the hell is this, and that they this is not what I signed up for. Okay, let's see. Where is the thing? It's bunker, probably. Bunker doors. Yeah, I don't worry. No, that's not it. I typically gain them back, you know, the next day or so, but still, it's so funny to see this every time. Right here, so we have these guys here. These are too large for this entrance. I think these things are at 0.7, yeah. And I wonder if we want to make some changes to them, like while we're at it. Might want to do that. So I'll probably actually just append one of these guys, or both of them. Yeah, why not both of them? Because then we can do the same thing I did here, where I actually have like a little bit of different sort of painting on top of them. You know, compared to the other one. So, the question is, should I just actually take this tunnel entrance? This is now quick mesh. I could maybe yank it out of the Blender Sync system and into its own proper file, and then we could have the doors there in the same file. I think that's probably a pretty good idea. So let's do means data static props. So this is another thing that we might want to actually make this into sort of like a generic entrance that can be used in a number of places. So if we have it like this, if this is the entrance piece, we can fit in a bunch of different places. Then, you know, we could even theoretically use this for something like a building somewhere. So maybe that's what I'll actually want to do here. So let's do that. I'm going to show you what I mean here. So let's reset the rotation here. I'm going to save a copy of this guy to the desktop. Again, loading the desktop is somehow slow here. I don't know what's going on. There we go. Blender Sync target. That's fine. And then we can cancel this edit. We didn't actually do anything there interesting at all. Like so. And now we'll take actually, yeah, we have the bunker doors there. Actually create a new blender that's not connected to Blender Sync. Just delete that. And we'll append from the desktop. Again, it takes a while. I'm going to append both of these actually. And we need to rotate this guy by this magical number. Yeah, it's not negative, it's positive. There we go. So now we have it there in world space and everything. That's nice. And I'm gonna take actually these doors away. First of all,
Join by distance. Geometry data, clear that. Thank you very much. Flat. There we go. So now then, yeah, this is what I want. I want to get rid of that door and that door. Bye bye vertices. And I can get rid of even some more here actually. Some of these like half included rocks and whatnot. Just to make this file a little nicer to work with. So there we go. There's another wheel there, and I think we have another one here as well. Yes. Like so. All right. And this looks kind of strange because like this grid is not actually aligned with the world now. But that's just this background object, which is not actually going to be used for anything. It's just to show this environment where this thing is going to be actually sitting. So let's make maybe a new collection here. Hey Arcane, welcome back for the second time today. What's going on? Right, so now we have the entrance and we want to save this as I think something inside of the static props. Let's just call this like double door entrance, something like that, right? Work. Because I assume we're gonna want to have some other things in the future where this might be handy to have. I don't want to make my sort of distinct entrances for all different places. We already had the bunker entrance, which doesn't quite work here because it is well, it's found in a resource pack that we don't want to load everywhere. But I think this one is going to be quite fine. We have some pretty lightweight objects here, and then some just very sort of generally useful ones. You know, like Santa Claus, for example. Like this guy is obviously super useful to have everywhere. I'm sure you agree. So double door entrance. And then we take append. And we append from where do we append from? We append from probably map refinery, bunker, work, bunker doors, left door and right door. Append those both of them. There we go. And scale 0.7 and scale 0.7. Oh. We want all of the stuff. The wheels got left out. So scale 0.7. Scale 0.7. There we go. vertex active. That should be the default in my opinion. Grab X. There we go. Now we have something to snap to. Yep, that's it. And then we have this one. There we go. And then we need to bring it up. And we need to bring it up so that it's just sitting on top of the or sort of like inside of this what do you call it? Track, I guess is the correct term here. One second, I'm getting a phone call. Alright, sorry about that. Let's have a look here. I think we need to probably like center these things. Yeah, it's intersecting there with that a little bit. That we can fix. It's no problem. I'm gonna want to take this guy and bring everything up the same height. And then I want to bring it over to about there. And that still doesn't intersect with anything. Nope, that's good. That would be good. So there, I think those are that's like the correct placement now for those doors. Do I actually want to modify those? Maybe I don't. Maybe I'm just like whatever. maybe they're good enough. I'm gonna want to bring their resources over though, so that I actually have like distinct materials and textures for them. Even though that seems a little silly, why have them twice? But that's because I want to kind of I want to make this resource pack sort of like self-containing in this instance. But yeah, that should be fine. Let's do that. So let's have a look-see here. What do we have? We have the shader editor. Right, material door. Well, it kind of looks like the Blender is freezing here on me. Bunker doors color placement, bunker doors diffuse. Yeah, okay. So we just basically want to make a copy of those. So if we go to the place where we actually found those bunkers, map refinery, bunker doors. This should have. Oh, that's a material. I want the diffuse. There we go. Yeah, so this should contain like both of them now, and it does look like it does. Yeah, okay. Okay. That's probably fine. So bunker doors is right there. Yep. Okay. Let's copy those guys over into double door entrance. Yeah. Like so. That'll be fine. And then we'll go to the image editor. And just remove all of these guys. Why is this so slow? It's like a very large. Okay, it was just rendering something probably in the background. Okay, that's fine. Okay, so we go here. We don't have the bunker doors, but we have the double doors, as it's called, as they are called. So image editor. Let's just open it, and we go here to objects, static props, double door entrance, work, all of those. Bring them in. Yep. I'll typically take away those PNGs at the end. And we even have some painted dirt and things like that. So double doors color placement, double doors diffuse, double doors painted details, and edge highlights. Right, that looks better. The reason I click the revert thing is that, like, if you've orphaned an image, Blender kind of doesn't really get rid of it until you've reopened the file or clicked revert. And so now that we've done that, we only have the double doors one. We don't have the bunker doors files there anymore. That's kind of like the point. Again, it's very, very slow. You can see my mouse cursor is just like the rendering is just lagging behind. I wonder what Blender is actually doing there in the beginning. Super laggy. All right. So the next thing then would be probably to make the material for this thing. Let's actually look at the bunker entrance itself. That's not it, and that's not it, but here is where it is. And I think this material uses some sort of, yeah, it's like a concrete thing, right? Concrete slab. So what's the material like? So the color placement, which is probably like empty, because I think this thing is just the same color everywhere. There's really no difference to anything here. Right, that was the color placement. Then we have the diffuse, which is sort of like the output. We have the painted details, of which there are actually some, and then we have the edge highlights. And then we have some sort of, yeah, we have the terrain pattern, which again is this thing that just has this pattern of these darker spots everywhere, almost like a noise.
And then that's the base color, so that's sort of like the kind of concrete color, if you will. So let's use the same material, I think, in the other one. I think that makes sense. And I wonder if the easiest way to do that would actually be to sort of append that. Let's append from bunker entrance on the material entrance. So we want that to be material entrance, like so. And of course it's using the wrong textures here. We don't want that, so let's do text console. I'm gonna open my handy little script here, which creates a bunch of files for me. What? That's no. Where's that file actually? It's a Python file. Let's have a look, see. Voronoi dirt, that's not it. Blender scripts, there we go. Create standard images.py. Yes, that's it. So, tools, Blender scripts, create standard images.py. That's better. Okay, good. So, entrance. Maybe we'll call it double door entrance. Something like that, and it creates 4 images for us. The diffuse one, the edge highlights, color placement, and painted details. So that's nice. Let's just click that, and we'll create this at 2K. And that means that we might not actually need all of the 2K fidelity for this. But we can downscale it then from the asset browser when we actually convert it to like block compression or whatever. So painted details and then edge highlights. I'm gonna switch back to OpenGL because the Vulkan setting there didn't actually do anything for the baking performance, right? What is this? That's the bunker entrance. We don't want to save that. So switching back to OpenGL because I'm having a feeling that like the performance is just better with this. Right. Okay. So here we have a little bit of concrete pattern going on here with this guy. So we might want to change the scale for that. I'm not exactly sure. But we'll see. Asset browser, we should have the edge highlight material, and now of course it is once again a little scary what will actually happen with this guy if we can actually use it. Edge highlights. And we need to set it from EV to cycles. And there we go. We have our edges highlighted. Let's hide those two guys. Hide and hide. All right. That looks decent. Let's see if we can actually bake this now. So with the material, it's not material door, it is material edge highlights. Double door entrance edge highlights. That looks good. And we go to baking and do an emission bake. Let's make sure all of the there we go. Yeah, save all images, we don't need to do that. Oh, I'm getting a little ahead of myself, aren't I? Because we haven't actually UV unwrapped this guy. But that should be really easy in this case. Right, because this is very much like a boxy thing here. So let's add a seam there. Let's add it all the way down. Another one there. Yeah. Indeed. Yeah, I saw it as well. I was like, what is this? And then I realized, oh, I haven't actually unwrapped anything. But for once, we have a model that is easy to unwrap. Let's actually get rid of those for now. Yeah, we might actually just have to cut this into smaller pieces, just because we have these very nice sort of large sweeping areas that fold very nicely onto the UV map there, but they might just be so large that it can't actually pack them properly. So now if we unwrap this, and then we look at Zen UV, is there any stretching? There's really no stretching to speak of. Let's do a checker texture with maybe yeah, 24 is fine. That looks pretty good. And now we're gonna throw it to the beast, also known as Packmaster, and see what Packmaster can come up with for this particular setup. Packing is an art. I spend hours sometimes. Oh man, look at this. Look at this. Look at how much I spend. UV Packmaster 3. We do heuristic search. Enable that. And then we want quite a bit of margin actually. So let's do 0.8. And then we pack. And it's trying to find these setups, and this is what I was saying. These islands are so large that it can't actually find anything sensible. But yeah, I'm gonna want to show you something from my stream. Yeah, but we're gonna have to do something better than that. Look at this. Look at this beauty.
I don't remember if this is the final one, but this is the UV sheet for the gripper truck. I tried plugins. I'm just a control freak. Yeah, you should have Zen UV and UV Packmaster 3. Zen UV gives you all the control you want, and you can just mark like, hey, don't touch those islands. I want those islands untouched, and then you just keep going. See, means vehicles, gripper truck, probably like main diffuse. Yeah, here's the thing. I think this is the same as this. Kind of looks the same. Yeah, to be fair, like this is perhaps not the most optimally unwrapped model, but it's just like it has so many freaking nooks and crannies that it's kind of tricky actually to unwrap nicely. Right. Okay. What do we do about this now? If you don't want to actually add any geometry, these things, like this island and this island, are kind of giving us grief. Is basically what I'm trying to say here. So what we could do is just cut them up. Basically at any point, we could just add like a seam there, for example. But that would be kind of nasty. So what I'm actually thinking about doing here is that since these things don't come all the way down, I might actually just want to have some sort of small little detail up there. That would allow me to just cut it there. I made unwraps that have 0 unused pixels. It's not worth it except to easily satisfy my horizon. I mean, I can make one of those. I just have a quad and then I unwrap it and it has 0 unused pixels. I typically can't have that because I use these UV sets for light maps as well. That's actually why I want quite a bit of margin. Typically with these guys as well. Because I use light mapping with the same UV set. I can actually, like the engine supports light mapping with another set, but by default it uses the same one. And my workflow isn't really necessarily set up to like have multiple of them. So yeah, I'm just using the same one, and because of that, like, well, if you want to. Not all objects are light mapped, obviously, but a lot of them are, especially the static ones, and so I have some additional rules to how I unwrap. Like I don't do overlapping islands, and I need enough margin between the islands. In ASO I use spherical harmonics for lights so they don't use UVs. I use spherical harmonics for the dynamic ones as well, yeah. But not for the static ones. Right. Righty-o. How do we want to do this now? How much of this top is actually visible here? Yeah, it's quite a bit. Like I'm all ears if someone has a very good idea of like how to actually split this up into different into like smaller islands. but I can't quite think of anything super sensible. So I'm thinking I might just have to actually add some fun little detail there at the top. It can be as simple as this, basically. Take that, and then we bevel it. And then maybe we'll do like a add a cut right on top of the arch. Yeah. I guess you wrote that before I started doing it, but yeah, I started doing it before I saw you writing that. I mean, I could just have a seam there, of course, and then I could cut at that, but I don't want to do that for the reasons I just said. I do light mapping among other things, so I don't want to have a cut like right in the middle of a flat area if I can avoid it, right? So I'm just gonna do this. I'm gonna get rid of that, probably. Screw that up. Whoa, that's not what I wanted to do. I was gonna have to try maybe a couple of these cuts and see what actually like looks nice. And then let's also bring that in. Maybe we'll do it with the manifold extrusion. See if that works. Kind of seems to work. A little more. And now we get to do this. To do this here. Little thing. Then we can probably even, we can cut it there, because I specifically just want more islands here now, so that we can pack this more efficiently. All right, something like that. Okay, let's give this to the heuristic packer. Yeah, let's look at that. 0.57. I usually try to get to 0.7. If I get to 0.7, I'm kind of happy. But I have a feeling we won't quite reach that much this time around. It's pretty much done for now. Okay, so what are we thinking about this thing then? We could cut this up into smaller pieces as well. I'm thinking that the doors will actually, like, even when they are fully open, they will kind of go over that, so we don't need to necessarily have those parts be like the same island as the main one. All right, so now we're approaching 0.7, but we're not quite there yet. Okay, well, you can see what this does. I'm not sure it will actually add much of anything. Let's cut it there. Yeah, 0.66. It's those arches, those damn arches. They're wasting space. .671. Can we get to 0.68? What if I distort the UVs? Yeah, then I'll probably get a whole lot more. Like I probably don't want to do it, but I mean I can do some quadrifying of some of these things probably. Let's go to here, select like that one. If we quadrify that, what? That didn't quadrify the whole lot. Just brings that closer. That's interesting. Yeah, that's a transform one. I'm actually really bad at this. At using this Zen UV. That's why I typically just use it for the overlays more than anything. But quadrify is interesting because it like typically, yeah, straight and regular shaped island, but it apparently it kind of considered these to be regularly shaped and or straightened, probably because like most of the outer edges are straight already. So if we took, let's take just the vertex, made it like this, and then we took that island and we quadrified it. Ah, look at that! It still doesn't do anything. That's interesting. I don't think I've ever seen this sort of behavior with this. Let's wonkify it. That's what the tool would be called if it was a tool. It would be wonkify. Yeah, you can see it does some things, but not like a whole lot. It's interesting. Yeah. I mean, since we're mostly going to be just, you know, rendering this as like a what am I trying to say here? So this is going to be like a concrete piece, right? Piece of concrete. I bet we could actually just like do this and try to kind of flatten this a little bit, and then quadrify that. Only quadrifies the end. I expected more from this tool. That's sad. Yeah, we could just make it like this, and it would probably still work, you know. Quadrify. Wonder what does that look like now? Looks like that. I can't use mirror. No mirroring, no overlapping, nothing like that. But yeah, the problem is that you know, you don't want to do this because it's going to be visible in the light map, unfortunately. And it is actually, it's very, very visible in the light map if you do that. So if we allowed that, then yeah, I could back these a lot nicer. And of course, I mean, for something like this, I could just, for this very specific mesh, I could use a different UV set. And you could just do, you know, light map back. Yeah, okay, this this won't work with my light map setup. I don't know what light map setup this is made for. But anyway, we're not going to be doing that. We are going to be happy with what we have, I think. And that'll be the end of that. I'm just looking at this, like, can I do some things differently here? And I can, but I wonder if it's like worth it really. Because I think the really big problems that we have here UV wise are just like these guys, those and those. So yeah, I don't know, there's really like a whole lot we can do. We can add some more details here to those pieces if we want to. Can add another cut here, for example. Do I want to do that? I don't know. Maybe not. Maybe I don't want that. So we're just gonna go with this. Angle based, that looks good. And then I'm gonna do this, and I'm gonna go to UV Backmaster once again. Maybe I can bring the margin down a little bit, and that'll give us a few more fractions. You can use the align UVs option. Where would that be? For what? Sorry, I just kind of rambled on, so I kind of lost the context there. But you know what we can actually do, and you know what we probably should do? And that is just limit the... Yeah, I think this is gonna be the biggest gain. All right, yeah, okay, yeah, I see what you mean. Yeah, I think I've used that at some point, actually. The align. So it's basically like here, right? Align. Straighten. Yeah, and then you can do auto align. this of course doesn't really necessarily work on this guy. Is this what you meant, or is this some other one that I don't know about? Line rotation, yeah. Align auto. It's not really doing a whole lot. Straighten just turns it into a line, which is not super helpful. But what is going to be helpful is, because we get rid of basically 4 of these problematic, you have to have 1 row selected. Really? Okay, so like that, and then 1 row, you mean? You mean like a row of quads, probably, or something? Which is of course a little problematic because I don't have quads here. Yeah, okay. Regardless, so you mean like this one? And then align, straighten. Okay. Yeah, okay. Actually, this is not what I've done in the past, but this is kind of interesting. Let's see. Play with this a little bit. See what happens. So you can straighten this thing, for example, yeah, and it makes something like that. Yeah, sure. I mean, yeah. Just for shits and giggles, what we can do here is we can do this on all of these and then just see what we would actually get, right? So that one, align, straighten, that one, align and straighten, and then all of these, we can actually do them all in one go. All right, pack that, please. Yeah, you can see now we're getting somewhere. Now we're almost at 0.8. Like I'm not gonna use this, but it's just interesting to see what could be achieved with this trick. Yeah, okay, well, we're basically at 0.8, so I mean, yes, this would give us better texel density, but the texels are all effed up. So, what I'm gonna do instead, for this particular model, I think the best course of action here is to do this. We take that one, oh, come on. Seam selection here. All of those inside faces. And all of these inside faces. We're basically only interested in those sides, but why not? Let's get all of them, because those are going to be mostly blocked by the doors anyway. Just going to scale those down to like 0.6 maybe. Right, and then. There we go, now we have everything, and now we can pack that. And let's see what we can get out of this. 668. And that's kind of nice. Sometimes it finds, like, it takes a while for it to find any new ones, and then it finds a new one, and then it, like, immediately after that finds like 10 smaller improvements on top of that. But I think we've basically reached like the point of diminishing returns here, or basically like no returns here. Yeah, clearly it's not gonna get better than that, but I think this is gonna be quite enough for this guy. And kind of crucially, it allows us to have this very nice sort of layout here for these large pieces. So that's nice. Okay, so now we can go back to this. Right, the checker texture is messing with this now. Right, so let's make sure we have all of the images saved. We do. Good. And now we bake and emit. And let's see if this is, you know, as tricky to do as it was previously in the stream, or in the part 1 of the stream. It doesn't seem to be. Look at that. We are already baking. Yep, that looks good. So we have the edge highlights, and with that we can flip the thing over to the entrance. And we can see that, yes, we do have the edge highlights in place. Looks pretty good. And I might want to be happy with this for now. And then just paint some wear and tear in here later when I'm at my drawing screen, drawing display. So let's just do a quick diffuse. Let's do just color. I'm gonna have to save all images again. Make sure that's selected, and we bake that. Right, so now baking is suddenly just, you know, normally fast. It was just so abnormally super slow previously. I don't know what happened, but now it seems to be somehow resolved. So you know, whatever. Really kind of curious what the problem was previously when it took like 15 minutes to bake anything. Right, so we are here. We have double door entrance diffuse. And now that, you know, baking is normal again, we might want to actually bake this as well, just to be sure. So double doors diffuse, and we bake that as well, and then we save that as a copy outside of the thing. Yeah, look at this, it's just super fast now. Nice. So save that and save a copy outside of work. There we go. So now then, let's this stream still, I will export these guys, and I will add the materials and add the game object types, and then put all of those into the level, so that we can then see how they work, and then I can make some like incremental improvements to that. And then I think that's going to be it for today. So double door entrance left door or something, I don't know. Let's just call it double door left, and then that would be double door right, and this would be double door entrance. Like so. Yeah, I think that's it. Let's minimize that. No, it's actually this one, right? Now that's the bunker. I have too many of these things open now. It's this one. Double door entrance. Here we go. So, in the asset browser, if we refresh that and we go to double door, so we have double door diffuse. This is a 2K texture. I'm just going to bring it down to a 1K here as part of the export. I'm going to make it BC7. Like so. And then we can bump it up again if we really need to. I'm going to do the same with this. BC7. So there we go. And these things should have gotten exported, and they did. Yeah, I should really write the size, the file size here, as part of the texture conversion. That would be nice. But oh well. Because you kind of don't really see the file size until you well, you can figure out the file size from code when you request the texture, and if you build the pack files, you get to use the pack file inspector to see how much space those things actually take. But it would be kind of nice to you know, not have to do any of that. One more thing that I want to do. I want to go do the double door entrance and tick physics data on for that, so that we can just use that directly. And then I'm gonna want to actually have a look here at the bunker stuff one more time, because those things probably used completely different materials. Like this is the bunker doors. This is probably a light probe. Yeah, okay, so the editor kind of opens up on this side. That's a little unfortunate. Let's open that again. So we can see that it's a material variant called bunker doors. It's based on a base material diffused light probe material. And the entrance is probably a light mapped. Yes. The same thing, but it's based on base material diffused light mapped. Okay. Alright. So we're gonna use that actually. Why not actually do it just this way? So we create material variant, file, save this variant as objects, static props, double door entrance, double door entrance. And then we can find the double door entrance. What's that? That's the one. And then we export that. And then we take the other one, this one, and again we shut that down, and then we create another material variant for this. So save double doors. the other one? Double doors diffuse, yes. And then, go into blueprints. Static props. Now, like, the props aren't necessarily completely static, like the doors can move and all of that. But it's mostly a static prop, right? Let's just make a new one here and call it static props. Double. Well, I guess it might make sense to put it actually in as like the blue gameplay objects. These are mostly like systems. These are kind of objects. Yeah, it's more a static prop than it is like a gameplay object. Yeah, okay, so I'm just gonna put it in static props. I changed my mind. So static props, double door left. And what do we actually use? We probably use like a, let's see, gameplay blueprints, refinery, blueprints, bunker door left. So this one uses a dynamic body transform as we already established. And it has just a box. Okay. Yes. Cool. Static props. Double door left. So we'll add a dynamic body transform component. That adds a box there. Then we'll add a mesh component. It's a dynamic mesh. Left. Bunker door left. Why don't we actually see that FBX thing? Double door left. Oh no. Yeah, that doesn't like it when you don't give it any sort of mesh. Let's restart this. It might be that it hasn't refreshed the paths there. Blueprint. Static props. Double door left. Double door left. There we go. That's not it. Left. Doors. There we go. Now it should work. And it does. Good. So this one needs to be much higher, taller. 5, 8, 7. Okay, 12. That's a bit too much. Yeah, that looks good. And then probably like 10 as well. 5? Is it -5 maybe? There we go. That's kind of nice. And then maybe we'll make it like 0.6 or something. Yeah, that looks good. That is good. Okay, so it's a kinematic object. That's important. Otherwise, it would just fall over when you place it in the level. Allow sleeping, sync sleep state. Yeah, it doesn't really matter since it's not like a true dynamic object. And the mesh is a dynamic mesh. That's nice. Blocks nav mesh. No, we don't want to block the nav mesh with this. Instead, what we want to do is like when these doors are closed, we're going to want to add a dynamic nav mesh obstacle there, so the AI doesn't just drive through it. The rest of the stuff should be fine. And then we can take duplicate and we just do the right door instead. And that would be just right. And then minus, no, actually positive 5 there. There we go. Right, that should be everything we need, I think. And then we need the other one, so static props / double door entrance. And for this we're going to use a static body transform component, because that allows us to use the tri-mesh double door entrance. It's right there. And there we can see that we actually have the physics already showing. And then we need a mesh component, and that would also be entrance double door entrance is right there. Yep, that looks good. It's not dynamic and it does block the nav mesh, and the rest should be fine, I think. Wonder why the static body transform component has like a kinematic flag here. Maybe they can be set as kinematics. I don't remember. OBS does something funky. Hopefully the stream is still good. Now the important part here is that we mark this as default ground. Otherwise we can't actually drive over this threshold here. What is that actually? It's just default. That's probably fine. Yeah, that looks good. Yeah, this material looks super boring here when we haven't painted anything on it, and there's no light map or anything. It's gonna get all of those things, and then it's gonna look nice. So the only thing we need to do now then is to reload the backend. And that, of course, is because the blueprints are only loaded when the engine starts, so you can't add new blueprints without restarting the engine. It's a little unfortunate, but that's how it works currently. And now then, what I typically do, as I've said before, is that I move these quick meshes underground, quite simply. So let's do tunnel entrance quick mesh. Let's rename it that. And I will probably move it so that it goes into this thing, which is probably already here. Another 50, and it should fit kind of nicely here. That looks good. And the reason I do it like this is that, like, once I know that I don't need these quick meshes anymore, I will remove them. But for the time being, I'm going to keep them here, because the quick meshes are stored in the level data. So if I just delete them, destroy them outright, I'm going to have to go look through my source control for them if I need them back. They're not stored anywhere else. And so that's just an easy way to
have them at hand if I need them before this level is done. So double door left. Let's take the transform of that and apply it to double door left. And then double door right. Same thing with that. And there we go, there's our double door. It might be kind of nice to have these things actually open. So maybe we'll do that as the last thing actually in this stream, right? Maybe we'll script them to actually open, because otherwise we're gonna sort of cut off a whole piece of this level from ourselves if we don't have a way to open them. So of course you can just drive up to those things and delete them with the debug overlay. So just bonk, we drive into them, and then we go like, nah, I don't want you. Go away. And then now we can drive there. But that's a bit lame. So what if we just have a script that we can run that opens the doors? Because we're gonna need that for the eventual mission anyway. For that to be done, I better go have a look at how I did it in the demo level. No, that's not the correct one. It is finery blockout. Because this level has a script that does exactly that, and it actually even moves those doors in a similar way, sort of to the side. So let's go have a look at how I did it here. So it would be like these two guys. Control script. Yep. Sliding door 1. Open. Oh, these are like actual scriptable objects. Right, okay. Okay, yeah, it's probably actually fine. We're just gonna add one of these. So they have a transform animation component that we can drive with the script. And that's fine. Okay. So we have a transform animation, animation data block name. So it comes from this is path animation 1, right? Path animation is here. And this is the actual animation. You can drive anything that has a transform. You can drive with this animation. And this animation is built up of a curve path. Curve path has one waypoint there and another waypoint probably, yeah, inside the building. Exactly. So yeah, this is a bit more involved than I remember, but hey, it's fine. Let's make those objects actually have a transform animation, and then we can control them. That's fine. And the nav mesh obstacle. Yeah, so it basically like controls all of the things from the same one, right? Open and close. Because this guy, when we send the message open to it, we play the animation. Here we play it forwards, and then we call play. Here we play it backwards, and then we call play. Or set the speed to be backwards, whatever. And at the same time, we remove the nav mesh obstacles. So there's one nav mesh obstacle.
And unfortunately you can't actually see that in the editor here. We should probably make it so that you can see them. What is that? That's a mean scripted nav mesh obstacle component. Okay. Well, yeah, it has a couple of them because it's so long. But yeah, I don't think I'm gonna add the obstacles there tonight. But let's do the animation at least. We don't even have a nav mesh in that other level though. Sliding door base. Yeah, that's just it. That's just that thing. Okay. So we're gonna need like the door itself, which we already have. We just need to make it scriptable. I'm gonna need a path animation. I'm gonna need the curve path, which is actually like used to create the animation. So all of those things. All of those things we're gonna need for one door. And then we have the other door is essentially the same, but like same but different. Same but different. Okay. And then a control script to actually like open and close them. Cool. Okay, I'm gonna do all of this tonight still, but I'm gonna take like a 50-minute break. So let's put on a quick break screen here. And we'll take care of some family business, and I will be back in about 15 minutes, and then we're gonna actually do the scripting business. So do stick around if that looks interesting. What if you need to run? Thanks for hanging out today. See you maybe next time. Otherwise, see you in a little bit. Hello, hello. What's going on? Let's try to remember to take the quick break visual away, because I recently put those into OBS. Previously I just had them as like full screen images in the image viewer, and I don't do that anymore because it's a little clunky. Now I have them as images in OBS instead, but that means that I need to remember to actually remove them, because they're not actually like visible here on my screen. Rightio, okay. So let's add these animations now to the thing. So I need to kind of somehow get a good enough glimpse here of what we actually want, so that I can sort of replicate this in the other thing. I'm gonna copy paste that script, put it there. I think that is probably like the only script we need. We don't really need these nav mesh things, as I said. The curve path is just a curve path. Position path direction. Yeah. Okay. So we have this animation here, which is what is actually going to like be driven here. Let's see. We have a couple of editor waypoints. These are actually locked. That's why they're that is why their bounding boxes are yellow, right? So you can't actually click them normally like this. Like it just doesn't, nothing hits it unless you hold down Alt, in which case all the locked boxes are also clickable. Anyway, that's neither here nor there. We have two editor waypoints, one out here and and one inside of the wall over there. Here. And so we then have a curved path that just leads from one to another. It's just a straight path here. But it's technically a Bezier path because it could be curved. And then we have a path animation, which is set to be 10 seconds long, running at 60 frames. And the position path is like this curve path that we looked at. And then we sample it with a curve. So if we look at this, actually yeah, we need to do it like this, right? Because it's just a Jesus, I'm just really losing my voice here. This is just a normal S curve, smooth normalized, but we can do it in a number of different ways, or an infinite number of different ways, because it's just a curve. Then we have the look at target mode. So where? Oh, right, okay. Yes, okay, I'm just thinking about like how the ramifications of this here. So position, path, direction, you can animate the rotation and the position of the object, and the position path is taken from this. You can also have a look at target path, which gives us another path to work with. So if you have like a camera that kind of like moves smoothly through the scene and looks at some other point that is also moving about, you can use that. You can use the position path direction, which just means that like it takes the direction of the position path, so it moves kind of like a train. You can do that with an offset if you want to, or you can just have it like look at a specific object the whole time. Those are all the things. And I was thinking like, okay, wouldn't that actually like rotate the
the door as it is moving here. And the thing I didn't remember was that this transform animation component actually has like a animate position, animate rotation. So this is like not checked its rotation thing here. So that is why this probably works. Because like the front of the door is this way. So if we animated the rotation, it would flip like this, right? And then move in this way, because the front, it's moving sort of like along the front, looking along the curve essentially, right? If that makes sense. But yeah, we're not animating the rotation there, so that should be fine. So if we can build this and preview it, and you can see that okay, this is what it will look like. We just have this this kind of like transform tree axis there, rotating or moving in this case. I don't know how you can stream for so long. I usually tap out of the 2 hours. It's fine. I've done like 10-hour streams. It's fine. You just need to take breaks and then occasionally do other things. I mean, I started at like maybe 1 in the afternoon today. I don't know. I never remember your folks' AMs and PMs, so I'm not gonna say any AMs or PMs. I'm just gonna say 1 in the afternoon, and it's like 10 in the evening now. So I'm doing almost nothing but stream today. It's fine. Okay. So that's the animation. That's fine. Maybe I have enough to actually work with here. So transform animation. So this would be means.transform animation component. It's one of those that we need to add to the door. Right. And that should be good. While we're at it, I'm going to check one thing here. Let's go to basis. And finally we should be able to actually build this thing, right? We've had that not being able to write the exe file there for like hours now. So static transform, static body transform, kinematic. Yeah, there's no kinematic thing here at all. And so I'm wondering why is there a kinematic flag here? There should be no such thing. Static body transform blueprint properties. It has shape descriptions, material names, tri-mesh resource paths, shape count, and rigid body description. This kinematic flag is just there, like it's just incorrect. Oh well. Let's not worry about that right now. Instead, just look at this means dot, what was it? Transform animation component. So how heavy is this guy? It's not super heavy. The nice thing about this thing is that you can run the script on the server. That's typically where scripts will run. You can run scripts on the client, but that's not normally where they are run. And this is networked, this component, so you can run things on the server and they will be visible on the client as well, which is of course very important because this thing is actually moving physics around. So let's see, how does it actually have an animation block, animation data block name. Out of that we get a data block with a transform animation that we get out of it, and then the transform animation player, and then we quite simply set position, set orientation. Okay. And since it is set to kinematic, it should just actually do like the whole kinematic thing. what's it called, like set kinematic target or whatever. Set physics transform. So if we are kinematic, right, there's a weird thing here with like if we have editor included, we don't actually want to do any sort of kinematic targets in the editor. We just want to set the world transform. Yeah. So set position. I'm just trying to figure out here if it actually does this kinematic target thing correctly. Set position. Is that actually a function? Yep, it is. Transform API, set position. Go there, please. Set position, transform, sets transform, and it sets teleport to false. Okay, teleport to false. Right, okay, this doesn't use it because this is the base class for the transform component, but if we look at this in the dynamic body transform, yeah, that's where we're getting it. So we are setting it here with teleport set to false, and then we come here, and that is not true. So we set the kinematic target. Yeah, so this should work fine, and it should push objects out of the way and all of that if they are in the way. Let's do just a very quick test here. Go into the refinery blockout level. And just make sure that put a vehicle here. Well, first of all, we need to open the doors. Open main gate, and then let's put a car here. Let's put a car right there. Scout. Boom. So now if we close the doors, close main gate. Does it actually? Yeah, that looks nice. Looks like it's working. It's kind of like properly pushing it. Oh, now it's gonna be in trouble. Yeah, a little bit. That was just because the wheel was kind of stuck there in the between the doors. Okay, so that looks like a pretty good way to do it. Just wanted to make sure because it's been quite a long time since I actually made that opening and closing. So transform, moving transform parent component. That's not the one. What was the name of the component that we wanted to add to those doors? I don't remember anymore. Means transform animation component. Okay, that might be one of these things that like don't actually have any metadata here in the asset browser, so this thing doesn't know about it. Yeah, kind of looks like that is the case. Oh no, I'm not doing it the wrong way. Like so. And then this would be transform animation. Okay. Yes. Hey Matt, welcome back. I am approaching the end of this stream, but what I'm gonna do is add an opening and closing animation to a new set of doors that I added to the depot level. So that's what I'm trying to remember how to do here. So transform animation needs to go on the client and the server. The server because the script will be running on the server, and the client because we want to actually move the mesh. That makes sense. Right. And yeah, double door right, same thing here. Transform animation. Yes. Just complains that it doesn't know about that component. Are you sure you want to add it? Yes. Trust me, bro. So let's build something as a prototype to actually move one of these guys, and then let's see how that works. So let's go into depot. We have to let it render these thumbnails before we can actually move around smoothly. It's jerky as all hell before that. There we go. So this guy. First of all, we can see that okay, now it is scriptable. Because it's scripting this transform animation component. So that's neat. And we want to change some settings here in a bit. But before that, let's try to get this actual animation working first. So we can do it like this. We can add a path animation under this guy. Right, and this was set to position path direction. And we need to give it a position path. Animation length 10 seconds, animation frame rate 60. Those might be fine. That's probably fine. But let's add a couple of waypoints here. Oh, actually, we need the path first of all. So curve path. All right. So just like we did with that, I'm gonna add it underneath this one. Curve path 1, that's probably fine. And as children of the curve path 1, we're gonna want to add the waypoints. So waypoint 1 is right there, but we're gonna snap it to the center here, right? So that was that. And then if we wanted it to move like 6 steps, 6 world units, I'm gonna want to duplicate that and then move it 3 and 6. So that's the end, right? And here we can already see that it's created this thing for us. All right. So now we should be able to copy that path and add it here. Position path is there, build and preview. We can see it already seems to work. And it has the nice like smooth start and end and all of that. That's kind of neat. Okay. So path animation 1. I think path animation 1 builds its animation data into a data block that has the same name as the actual object. So we should just be able to paste that into there. What is the full name? Quarry tunnel entrance double door left path animation 1. Yeah. Something like that, right? And then we can have a look at the script that we used there in the other one. And it's basically just this. So let's copy that over there.
comment out these nav mesh things. They can be there as a reminder for me how to do it then when I actually want to have the nav mesh obstacles there. Okay, so the thing that now remains to be added is some sort of control script that controls both of them. So let's add a script here. I think a script is just common script is just fine. And to this we will add a dev annotated function called open tunnel gate. And this will send a message. The receiver is quarry tunnel entrance double door left. The message is was it open? Yeah, open and close. So open, and then we have close. Right. Is that all we need? I think it probably kind of is. Control script is what we could call that thing. Yeah, scripting can be a little fiddly in this engine. Specifically with how objects are referred to and all of that. Open tunnel gate. All right. Okay. Yeah. So now we have that. Now we have that issue that I forgot to set that one flag here, or actually uncheck it. So this thing is not supposed to animate the rotation. All right. Only the position. Open tunnel gate. Yeah. Isn't that nice? You can sort of see into that a little bit, but like nothing that's gonna be a problem. Like, because this thing is actually not like deep enough to actually contain the whole door, but like, yeah, I don't care. I don't care. It's quite good enough. It's quite good enough. Okay, excellent. So let's do the same thing for the other door then. So this guy, let's untick that rotation one right away. Right, and the first thing we'll want to have here is again a path animation. And then we're going to want to have a curve path. And again, under the curve path, we're going to want to have an editor waypoint, which is there. Move it to the center there, and another one which is 3 and 6 away. And I think we're gonna do the same thing here. We're gonna lock these objects so that we don't accidentally move them, like so. Curve path, and that's good. And path animation. This is now that path. So position path is that, And that's direction and build and preview. Now they're moving in like opposite directions. Nice. Nice, nice. So then we just do the same thing for the double door right. Yep, that might be it. And I wonder if we actually want to keep this like just like open by default, and only close it if the level is active. That might actually be the best thing. So now it's slowly opening, slowly and smoothly and nicely. Let's add some crap in here. See what happens if we close this now. Close tunnel gate. Oh Lord. Yeah, well, it kind of handles it as well as one can expect. What actually happens now? It just jump back? Nah, nothing seems to happen. Now it jumps. It just doesn't jump when the animation is actually ongoing. Okay. Oh, you can actually... Okay. Okay. You just can't open it while it is being opened. That's fine. Anyway, yeah, this is fun. Seems to work pretty well, and now I have like a rudimentary gate here, which is the important part, because I'm gonna need it for the mission kind of soonish. So that's always fun. Right, close. Interesting thing here is that, like, okay, if we had an obstacle to the, if we add a nav mesh obstacle to the level, I think it's gonna be there by default, and that would actually kind of, it would work just like it does in that other level where the gate is closed by default. But if we add it here and we want the gate to be open by default here, I wonder if that object actually supports kind of not being there by default. That's an interesting thing to consider. So let's open this by default. Boom, like this. That's that. You can't actually, like, you can't stop the preview once it is running. So now we have those two guys running there. I need to just reload the backend again to have them stop. That's a bit stupid. Okay. So nav mesh obstacle. scripted nav mesh obstacle, right? Okay, and that creation it can actually be false, right? Obstacle type hard and radius 5. Yeah, okay, so add that creation, it can actually be false. That's nice to see. So scripted nav mesh obstacle component and add creation. Yeah. Okay, neat. So we'll just leave that as false then for this particular door. And it should actually fix it for us. Okay. Nice. I'm not gonna do that though yet though, because I don't really have a nav mesh at all for this level yet. Probably gonna have to start thinking about that soonish. That might be a kind of an interesting stream in and of itself, because there's a lot of like experimenting with that sort of thing, just like having AI agents navigating around the area and seeing like what works and what doesn't work, all of that stuff. So that can be kind of fun. But okay, this was a pretty good day. I got a whole lot of work done on this level. Basically, like this entry point here, this end of the level here is kind of well working now. I'd say it doesn't really look like the world is just ending in this direction. It kind of just looks like it is continuing. And unfortunately, you just can't go there. So I'm pretty happy with that look there, I'd say. Still not 100% happy with the backgrounds there. I have to work a bit more on that. Actually probably figure out what is supposed to be visible there in the distance and what is not. But this is nice. So now we have this thing here. Just making sure that collisions are accurate. They are good. Yeah, I think the top there, even the top works pretty well. We had to add this little sort of, I don't know what to call that, like a detail to the top there to be able to like split those up into sensible UV islands. It's like the most ridiculous reason to add one of those things, but I guess the detail works kind of well. So let's not worry about that. And then once I have those cliffs done, so I still have one cliff here in the other area, the other end of the level. Once I have this cliff textured, I can do that sort of like batch drawing thing where I just like draw wear and tear and weathering and crap onto the cliffs to make them look nice. Once that is done, I think I'm gonna have to turn my attention to this quarry here. Just start putting more details on some of these objects here. And then when that's done, or perhaps even before that, I don't exactly know, I am going to have to model this house here. I think we're going to need a little bit of an iteration on the actual level before that happens. There's supposed to be like a whole narrative thing here with this house.
iteration on that narrative side before we actually put any proper effort into the art side of that house. That might make sense to do. Oh yeah, lots of things to do still. I might stream some more of this level design this week. So if you're interested in that, be sure to check out the channel in the coming days. There's a little bit of work to be done here on the, actually probably quite a lot of work to be done here on the monorail as well. And the mother vehicle is supposed to get a new crane, like a second crane, which is probably to be used already in this mission. So that's going to be a whole thing, and we're going to need to actually like design and implement that crane properly, and it's going to be awesome. I actually have that crane. I have made that crane, the crappier version of that crane already previously. So if you've seen some like really old Zig videos from my channel, you might have seen a prototype of that crane already. It's pretty cool. It's very different from the cargo crane that we have today. So what happens if this vehicle gets stuck completely between those doors? Let's end with that. See what is happening. So, close tunnel gate. What happens if I do this? Oh no. Nothing good happens. It's not actually as completely broken as I thought it would be. It's pretty broken. But it doesn't go quite as bananas as I was thinking it might go. Let's open the tunnel gate again and let's see if we can actually have the thing come away. Yes. Wow, this is interesting. I don't think I've seen this before. It's just balancing on 3 wheels. Alright, yeah, well, if you're making a gate like that that actually can close, then you would probably need to have some sort of like security features on it, just like an actual gate in real life would have. But it's a little stupid to start thinking in terms of those things in a game like this. But of course, you know, most physics-driven games actually don't do this sort of thing for this specific reason. Because there can be so much jank. Like you can hold on to this door, and then you can close the tunnel gate, and you can see that it actually kind of just works. Oh no! Open, open, open.
thing just like holds on to it. Oh, okay, I clicked the wrong one. Yeah, most games are kind of afraid of physics for this very reason, that like these things just get janky kind of easily. Traction point is not afraid to be a little janky. Lovable jank. Lovable jank is always good. What is truck test? What does that do? Oh, it adds a truck full of stuff. That's cool. Alright folks, I think we're pretty much done for today. I've been doing this now for 8.5 hours today. So it's like a full work day of streaming. Actually more than a full work day of streaming. So that's fun. I hope it was fun for you as well. As always, I remind you that if you want to play the pre-alphas, you should go to the Madrigal Games Discord. There's a link in the description below. And there's also a link in the chat. I think I wrote one in the very beginning of the chat. And if you would like to see more of this kind of laid-back game dev, then I invite you to subscribe to the channel. I will also do a live stream pretty soon, I think. Just going to be something completely different. We're going to be doing audio. We're going to be doing audio specifically for the example mod, which I am preparing to open source and give to you guys, along with the pre-alpha 3 of Traction Point, which will release soonish. My initial hope was that I would release Traction pre-alpha 3 during August. We'll see if that actually, if I have time to do that, because that was kind of an optimistic thing, but not very long after August. Just a few things that I want to get. Some of them are actually kind of large. Mod support being one of them, and I have a plan for how I want to do mod support with audio, like the ability to actually add audio to your mods. And because of that, I'm thinking that the audio editor, so Timbre, my node-based audio editor creation tool, will be the first tool that I will actually release to you guys. If we don't count like mesh converters and things like that, that will be available to you, along with the rest of the modding SDK. But the actual kind of like graphical tool that I will release will be the audio tool, and I will do a live stream on how to use that together with the modding system. As soon as I get that actually working, there's a little bit of implementation there's still to be done. So if that sounds fun, keep an eye out for that as well. Long day at the live stream mines. Yeah, it was a pretty long day. Did have a little bit of a break in between, but it was pretty long, and I got quite a lot of stuff done, so that's nice. It's a good day at the live stream mines. Anyway, with that, I thank you for your time today. And wish you an excellent continuation of your day or evening or morning or night. Remember to like, subscribe, do all the YouTube jazz. And I will see you in the next one.